Let's travel back 66 million years. On that fateful day, a red-hot space traveler, a giant asteroid, slammed into the flesh of our planet at an incredible speed. The force of this impact was truly apocalyptic. It exceeded the power of all of humanity's nuclear arsenals combined. In a single, terrifying instant, the world that had belonged to the dinosaurs for more than 160 million years collapsed into an abyss of chaos. Ancient forests that had stood for centuries were transformed into gigantic funeral pyres. The sky, once blue, turned black with soot, and the air filled with cold and poison. For a long time, we humans imagined this picture as an instantaneous end, a full stop in the history of the great dinosaurs. But the truth, as often happens, turned out to be far more complex and dramatic. Not all dinosaurs perished in this fiery inferno. Individual groups clung desperately to life, hiding in the shadows of their world's ruins. They waged a daily battle against relentless hunger, endured bone-chilling nights, and tried to persevere in a reality that was crumbling. And most astonishingly, a small group of feathered dinosaurs managed to do more than just survive the catastrophe. They adapted, evolved, and gave rise to the very birds that soar above our heads today. So what was life like for the last dinosaurs after the skies fell upon Earth? Let's journey into the distant past, to an era when Earth was the kingdom of the Titans. From the colossal Brachiosaurus, stretching its neck to the crowns of the tallest trees, to the swift predators hunting in deadly packs, and the living ankylosaurs, armored in bone. These giants occupied every corner of the planet. Mammals played only supporting roles in this grand drama of life, hiding in the shadow of the titans. But when the apocalypse struck, it was the giants who fell first, and the world changed forever. Only those who could adapt survived. This reversal of fate is one of the most dramatic chapters in the history of life on our planet. In the first few 100,000 years after the asteroid impact, mammals began cautiously to assume new roles in a world left without its former rulers. Countless ecological niches suddenly became empty. Forests, where herds of hadrosaurs once grazed, fell silent. The skies, once plied by flying reptiles like pterosaurs, became deserted. Even rivers and lakes, once the preserve of giant predators, became surprisingly safe. Mammals rushed to occupy these vacated spaces, adapting and evolving with astonishing speed to take advantage of the opportunities. At first, there weren't many of them. The planet was still unstable, and it took time for forests to recover and food chains to function again. But once the world regained a fragile equilibrium, a veritable evolutionary explosion began. Life on Earth began to change at a kaleidoscopic rate. Let's transport ourselves to the world as it were a moment before the heavens fell. Imagine this scene: endless expanses covered in giant ferns, mighty coniferous forests covering entire continents, meadows where tall grass sways in the warm breeze, and among them the bright flashes of the first flowering plants, opening their petals, beckoning myriads of insects, and in the depths of lakes, rivers, and oceans, algae blooms serenely, saturating the water with oxygen and serving as food for countless tiny creatures. But plants are more than just a picturesque backdrop to a prehistoric landscape. No, they are the foundation upon which the entire pyramid of life rests. They sustain every herbivorous creature, and it doesn't matter whether it's a tiny insect gnawing on a succulent leaf or a colossal sauropod tearing entire branches from the treetops. All of them, great and small, are utterly dependent on this verdant kingdom, and even the most ferocious predators, like the scourge of the Cretaceous Tyrannosaurus rex, only indirectly rest on this same foundation. After all, the herbivorous giants it hunts couldn't survive a day without their plant-based diet. This bond seems unbreakable, eternal, until a force intervenes that can tear it to shreds. Approximately 66 million years ago, this force emerged from outer space. A mountain-sized asteroid piercing the atmosphere slammed into Earth. The fiery explosion not only incinerated all life for thousands of kilometers around, it triggered a far more terrifying and long-lasting mechanism of destruction. Plants and the entire food chain that bound all life on the planet together were doomed. First, the Earth itself shook. Firestorms swept across forests and plains, transforming the verdant paradise into a scorched desert. Giant trees were uprooted, meadows turned to black ash, and entire ecosystems became charred, lifeless wastelands. But these fires were only a prelude. The true apocalypse was unfolding high in the sky. Dust, ash, and billions of tons of vaporized rock ejected by the monstrous impact filled the atmosphere. They wove together into a thick, suffocating blanket that, like a shroud, covered the entire planet, completely blocking out sunlight. Days turned into twilight, gloomy nights. Gradually, the world plunged into darkness. The sun's rays could no longer reach the surface, and without this vital energy source, photosynthesis, the great process that gives life to plants, first slowed, then stopped altogether. Plants lost all ability to produce food, grow, and sustain themselves. It was a rapid decline on a planetary scale. Even if a tree miraculously survived the fiery inferno, it was doomed to a slow death without sunlight. Grasses and flowers wilted, their leaves yellowed, turned brown, and fell off. Algae in the oceans, also dependent on light, ceased blooming. In just a few weeks, perhaps months, most of the green world was reduced to dust. In some regions, a freezing cold set in and frost covered the ground as the planet rapidly cooled without sunlight. Once lush tropical forests turned into dead cemeteries of bare trunks and fallen leaves. Grasslands became desolate fields with dry, brittle stems. Even the seeds that had lain dormant in the ground, awaiting their time, were unable to germinate. In a world where seedlings lacked both warmth and light, the first victims were those who fed on plants. Herbivorous dinosaurs, from the mighty horned Triceratops to the duck-billed hadrosaurs, suddenly found themselves in a world without food. Their vast herds, once numbering in the thousands, began to weaken and thin. Exhausted by hunger and despair, they must have wandered the deadlands for days in search of any food, finding only withered bushes or the blackened remains of forests. Particularly tragic was the fate of the giant sauropods, whose long necks were designed to reach the lush canopies of trees. Their colossal bodies required incredible amounts of food every day, and when the trees died, they died with them. The smaller herbivores fared no better. With food scarce, competition for survival devolved into brutal slaughter. Some died of starvation, while others, driven mad, tore each other apart in a desperate fight for the last edible root. But the tragedy of the herbivores was only the first act of this drama. Predators didn't remain on the sidelines for long. Soon after the destruction of the plants, a terrifying chain reaction began. At first, carnivorous giants like Tyrannosaurus may have even felt better. Weakened and starved, their prey was an easy target. But this feast on bones was short-lived. Weeks turned into months, and the prey itself began to disappear. When there are no herbivores left on the planet, predators are doomed too. Even the most powerful hunter cannot survive without food. And so, one by one, the great predators followed their prey into oblivion. The mighty pinnacle of the food chain collapsed, not in an instant, but as the final victim of a long downward spiral of death that began with the death of a simple green leaf. The ocean suffered no less, perhaps even more. Algae and phytoplankton, these microscopic organisms, were endless underwater meadows, the foundation of all marine life. They floated near the surface, converting sunlight into energy, and served as the first link in virtually every ocean food chain. They fed on tiny creatures, which in turn were eaten by fish. Larger fish preyed on smaller ones, and so on, until the chain reached the titans of the sea, whales, sharks, and giant marine reptiles. As the sky darkened and sunlight stopped penetrating the water column, these underwater meadows began to die off. The food chain collapsed almost instantly. Without plankton, entire schools of fish disappeared. And without fish, giant marine reptiles like mosasaurs and plesiosaurs were doomed to starve. Even the incredibly resilient ammonites, who had survived numerous global catastrophes, couldn't survive this one. This wasn't just a famine. It was a complete collapse of the global ecosystem, which had taken hundreds of millions of years to develop. Plants don't just provide us with food, they produce the oxygen we breathe. As vast tracts of forest and ocean plankton died, atmospheric oxygen levels likely plummeted. At the same time, rotting plant remains released carbon dioxide and other toxic fumes, further altering the climate. The Earth became a bleak, cold, and toxic place. Survival now meant more than just finding food. It was necessary to find shelter where the very air wouldn't be a deadly threat. But no matter how complete this collapse seemed, life has an astonishing ability to cling to existence. Not all plants perished. Some seeds remained dormant in the soil, riding out the apocalypse in a dormant state. Some incredibly resilient species, such as ferns, were able to quickly germinate right from the ashes of the destroyed world. Paleontologists are finding evidence in the fossil record of what scientists call a fern surge, a layer that appeared immediately after the asteroid impact. Where forests once flourished, everything suddenly became covered in dense thickets of ferns. These plants possess remarkable resilience. They can grow in poor soils and require little light. They became the first green shoots of hope, proof that life had not yet completely died out, and not every food chain was broken forever. In the oceans, some species of plankton managed to survive in deep or sheltered waters. Small animals that could feed on dead organic matter, not just living plants, also had a chance. These tiny creatures became the seeds from which new food webs sprouted. Slowly but surely, life began to recover. After the asteroid strike wiped out the plant world and destroyed the old order, the world changed beyond recognition. Dinosaurs, with all their might and majesty, couldn't survive a world without plants, but mammals, small and inconspicuous creatures at the time, proved better adapted. They survived by feeding on what was left: seeds, insects, and carrion. Birds, descendants of dinosaurs, also survived, perhaps because their ancestors could feed on seeds, which lasted much longer than green leaves. These survivors, standing on the ruins of the old world, began to build new food chains. And over time, it was from these new food chains that all the incredible diversity of life we see today arose. It's important to appreciate how sudden and ruthless these changes were. Imagine, one day, lush green forests and fertile plains spread across the planet, and just a few weeks or months later, the sky was different. Eternal night reigned, the air was icy cold, and the soil was bare and dead. Animals roamed, frantic with hunger, plants turned to dust, and the oceans, once teeming with life, became silent, aquatic deserts. The collapse of the plant world wasn't just the disappearance of greenery. It was the destruction of those very invisible threads that bound all life on the planet together. The lives of the largest dinosaurs to ever walk the earth were never a walk in the park. Yes, at first glance, they appear enormous and invulnerable. Some were longer than several buses lined up side by side and taller than any human. But these giants, like living mountains, waged a desperate daily struggle for survival in a world filled with both opportunity and deadly danger. To understand this struggle, we must imagine a planet in constant flux. Climates shifted, landscapes transformed, predators lurked in the shadows, and food sometimes became scarce. For large dinosaurs, the battle for survival wasn't just a test of their strength, it was a test of their endurance, intelligence, and adaptability. These animals weren't mindless monsters wandering aimlessly across the earth. They were complex creatures that faced hunger, thirst, harsh weather, injury, fierce competition, and the constant threat of predators every day. Their lives were a constant war. Let's move on to a world ruled by giants. Long-necked sauropods, true titans of prehistory, could grow to incredible sizes. Great predators like the fearsome Tyrannosaurus rex faced an equally complex dilemma. Hunting prey comparable in size was a deadly endeavor, even for a creature armed with dagger-sized teeth and crushing jaws. Every lunge, every attack was a courtesy call. After all, if a predator sustained an injury, even the most seemingly minor, it could be a death sentence. It would simply starve to death. These weren't modern lions which can survive and hunt even after serious injury. Many of these giant meat-eaters, scientists believe, were solitary hunters. This means they had no one to rely on if they were injured or had a misfortune. No one would bring them a piece of meat, no one would protect them from rivals. A broken tooth, a pulled muscle, or simply an unsuccessful chase, any of these factors could be the difference between life and death. For these apex predators, finding enough meat to feed their enormous bodies was as grueling and daily a task as finding plants for their sauropod prey. Another fundamental problem that defined their entire existence was access to water. Enormous dinosaurs simply could not survive far from the rivers, lakes, or swamps that served as their life-giving sources. During dry periods, when there was no rain for weeks or even months, these bodies of water would dry up or dry up completely. During such desperate times, entire herds were forced to undertake long marches in search of water. These migrations were not only incredibly tiring, but also deadly. Here, by the drying up water sources, the bloodiest dramas unfolded. The predators knew perfectly well where their prey would come. Lying in ambush, they patiently waited for the thirsty animals to come to them. Let's imagine this scene. Dozens of herbivores slowly trudged toward the last pool of murky water, and in the shadows of the trees and rocks, hungry killers lurked, ready to strike the weakest, the stragglers. Water was the source of life, but reaching it often meant risking everything. The struggle for survival was inextricably linked to the vagaries of the ancient climate. During the millions of years of dinosaur dominance, our planet experienced numerous global changes. At times, the climate was paradisiacal, warm, humid, with lush forests covering entire continents. During such eras, food was abundant, but these blessed times were followed by severe trials, severe droughts, catastrophic floods, and monstrous volcanic eruptions. When lava flowed from the depths of the earth and clouds of ash obscured the sky, life became hell. Volcanic ash could obscure the sun for weeks or months, killing plants and, consequently, causing mass starvation among herbivores. To find even the slightest food, they were forced to migrate vast distances, and when herbivores began to weaken and die, the same fate befell the predators as their food supply disappeared. Some mammal species began to rapidly increase in size, taking over the spaces once occupied by dinosaurs. In just a few million years, mammals the size of dogs, then pigs, and even bears appeared on the planet. The emergence of such large forms was made possible by the revival of plant life. Food sources became abundant once again. Forest mammals grew larger to feed on the new lush vegetation, and predators, in turn, evolved to hunt these new giants. This was the birth of a new era, which we now call the Age of Mammals. It led to the incredible diversity of species we see today. One of the key factors in the success of mammals was their incredible adaptability. Unlike reptiles, they were warm-blooded. This ability to generate and maintain body heat allowed them to remain active even in cool climates. In a world that had experienced a nuclear winter, this was a colossal advantage. They had fur, which provided excellent insulation and protection. Furthermore, their teeth were complex, allowing them to process food in a variety of ways. While many reptiles simply swallowed their prey whole, mammals could crush, cut, and grind it, opening up access to a wide variety of food sources. This flexibility helped them not only survive in the harshest conditions, but also thrive whenever a new opportunity arose. Another secret weapon was their method of reproduction. Mammals devoted enormous attention to their offspring, unlike most reptiles. Floods could wash away entire clutches of eggs and carry off helpless young, and droughts devastated entire populations. Climate was a silent but all-powerful enemy, one that dinosaurs could never defeat. They could only adapt and endure. Procreation, reproduction, and raising offspring. This was another brutal battle, the outcome of which determined the fate of the species. Despite their colossal size, most dinosaurs did not give birth to live young, but laid eggs. These eggs, although sometimes quite large, were incredibly fragile and defenseless against predators, the vagaries of the weather, and simple accidents. Entire nests could be destroyed by a flash flood, trampled by a migrating herd, or plundered by small, sneaky animals. for whom the eggs were easy and nutritious prey. For a female dinosaur, protecting her future offspring became a real battle. When she had to leave to search for food for herself, the nest was left unattended, and caring for the eggs became a nearly impossible task. The vast majority of baby dinosaurs never saw their first sunrise. This forced adults to lay dozens of eggs in the desperate hope that at least a few would hatch, survive, and grow. From a species survival standpoint, this was a system with enormous risks. But it was the only way they knew how to continue their lineage. The result was an endless cycle of struggle in which only the strongest, the most cunning, and the luckiest had a chance to continue this eternal relay of life. Diseases and injuries also played a devastating role in the daily lives of dinosaurs. Studying fossilized bones, paleontologists find evidence of a wide variety of ailments, traces of horrific infections, arthritis, healed fractures, and even cancerous tumors. For a gigantic animal weighing tens of tons, a broken leg was tantamount to a death sentence. Such an animal could no longer move in search of food or escape predators. Even a minor wound could become infected, and without antibiotics and medical attention, the infection would quickly lead to death. We see signs of healed injuries on some bones, demonstrating the incredible endurance and strength of these creatures. However, scientists are certain that the lives of countless dinosaurs were cut short precisely by accidents and disease. Survival here depended not only on size and strength, but also on sheer luck and the ability to withstand inhuman pain. Competition between species made their existence even more challenging. Enormous herbivores constantly vied with one another for access to the best pastures. Entire herds could engage in fierce battles on riverbanks or in fertile valleys, pushing weaker competitors onto the barren lands. Predators fought no less fiercely for dominance, challenging each other for territory or prey rights. Even within a single species, passions ran high. Males could engage in bloody duels over females or their status in the herd hierarchy. These clashes often left deep scars, broke bones, and frequently resulted in the death of one of the participants. Survival meant not only the ability to escape the dangers of the outside world, but also the ability to withstand constant conflicts with one's own kind. The size we've come to consider dinosaurs' greatest asset could also be their greatest curse. Moving such a massive body was slow and required colossal energy expenditure, making a quick escape from danger virtually impossible. Yes, a large sauropod could simply trample a smaller predator. But when an entire pack or a single gigantic apex predator was targeting it, the chances of escape were slim. The very mass that served as their armor also made them prisoners of their own bodies in certain situations. For example, when they became bogged down in swampy soil or caught in a powerful river current. Fossil evidence confirms that some dinosaurs ended their lives in just such natural traps, unable to escape and becoming easy prey for scavengers. Thus, being enormous was both a blessing and a curse. The perpetual need for energy shaped the entire behavior of large dinosaurs. Some species may have formed huge herds for collective protection. Others likely relied on constant migration, following seasonal changes and shifting food sources. The movements of these giants likely shaped entire landscapes. They trampled forests, created wide trails, and even influenced plant growth by consuming them on an industrial scale. But behind this incredible power lay the endless need to move, eat, and survive, leaving very little time for rest or peace. This merciless struggle for survival wasn't limited to adults. Young dinosaurs, even those belonging to gigantic species, began their lives tiny and completely defenseless. A newly hatched sauropod was no bigger than a house cat compared to its giant parents. Predators lurked at every turn. Only through rapid growth and incredible luck could it hope to survive to adulthood. Fossilized footprints suggest that young dinosaurs often traveled in separate groups, perhaps for greater safety, while adult giants may have led a more solitary life. The transformation from a fragile infant to an indestructible colossus was an epic battle in itself, one that only a few ever survived. Millions of years of this relentless struggle shaped dinosaur evolution, forcing them to adapt in the most bizarre ways. Long necks allowed sauropods to reach the canopies of tall trees, reducing competition with smaller herbivores. Their gigantic size provided reliable protection from most predators, although it also required increasingly larger amounts of food. Razor-sharp teeth and powerful jaws provided predators with ideal killing tools, and heightened senses helped them track prey even more effectively. However, each new adaptation, which solved one problem, inevitably created new challenges. We often look at the fossilized remains of prehistoric titans and involuntarily imagine them as the invincible rulers of an ancient planet. Looking at these gigantic bones, it's easy to imagine a world where these colossi were absolute monarchs, the invincible masters of their era. But behind this facade of boundless grandeur lurked a far harsher and more brutal reality. Their lives were not a triumphal march, but a daily, grueling struggle to maintain a fragile balance for the very right to exist. Every day for these giants was filled with uncertainty, desperate struggle, and mortal danger. Let's travel back to the Mesozoic era. Ancient forests, endless plains, and swampy swamps were not tranquil paradises. No, these were gigantic arenas, fields of ceaseless battles where the verdict of life or death was rendered every second. Every roar emanating from the thicket, every clash of titans, every heavy step they took across the ancient land was just another episode in an endless saga of survival, in a world that gave no one any leeway. And when the hour of great catastrophe arrived, it was the tiny dinosaurs who had an incomparably better chance of surviving the apocalypse, which put a bold end to the age of giants. The reasons for this paradox are as fascinating as they are tragic. To understand it all, we need to imagine the world more than 6 million years ago. On that fateful day, a fiery projectile the size of a mountain slammed into the earth. This single monstrous impact shook the very foundation of the planet, causing the oceans to boil and forests to turn to ash. The entire world around us burst into flames, and this event ended the reign of powerful beings who had reigned supreme on Earth for over 160 million years. In this apocalyptic chaos, the rules of the game changed forever. The winners were not the largest or the most ferocious. No, the right to a future belonged to those who were smaller, more agile, and far more adapted to the new realities. Their survival was the result of incredible flexibility, natural ingenuity, and, of course, a bit of luck in this merciless and dying world. Let's remember the colossi we've lost. the colossal sauropods, whose bodies stretched the length of several modern city buses. Their necks, like living construction cranes, reached to the crowns of the tallest trees. Or take the fearsome Tyrannosaurus rex, a predator with jaws so crushingly powerful that its prey had no chance of escape. But in the new world born of fire and ashes, it wasn't these majestic monsters that survived. Those who could move quickly, think quickly, and adapt quickly survived. They laid the foundation for a new era, where the key to success was no longer brute force, but the ability to adapt to the blows of fate. These majestic creatures found themselves trapped by their own size. Their gigantic bodies were insatiable machines requiring incredible amounts of fuel every single day. Tons and tons of vegetation for long-necked herbivores or an endless stream of fresh meat for apex predators. Their appetites were truly colossal. And when the asteroid struck the planet, it was precisely this insatiability that became their death sentence. The forests burned to the ground. A thick blanket of ash covered the sky, plunging the world into darkness. Plants, deprived of sunlight, began to wither and die. And with the disappearance of flora, the entire food chain collapsed. For enormous creatures whose metabolism required constant nourishment, survival became mathematically impossible. Meanwhile, in the shadow of the dying giants, those often overlooked by history bustled about. Tiny dinosaurs, no larger than a modern chicken or turkey, lived by entirely different rules. Their needs were 100 times more modest. They could survive on a handful of surviving seeds, search for insects in the ashes, or catch a nimble lizard among the rubble of a burned-out world. Some of these tiny creatures even had specialized beaks, perfectly adapted for cracking hard seeds that could survive both fire and cold, hiding deep underground. Others relied on their incredible speed and agility to hunt insects or find the remains of fallen giants. In this new hungry world, where every calorie was precious, their modest size suddenly became a major evolutionary advantage. They had another, no less important ace up their sleeve. Small dinosaurs could reproduce at an incredible rate, and their offspring needed much less time to mature. Just think about it. A giant sauropod could need decades to reach its full size, decades of stability and abundant food just to grow. Even a super predator, like a Tyrannosaurus rex, required vast hunting grounds to feed its young. Each new generation of giants was critically dependent on the predictability of the environment, but a small dinosaur could lay a clutch of several eggs, and its offspring would grow up in just a few months or a year. Even if many perished in the harsh conditions, some would always survive. This ability to quickly regenerate populations allowed small species to stay afloat, even when disaster struck one after another. A smaller body size also meant a smaller territory. Large predators had to patrol vast areas in search of prey. Once their prey disappeared, they were doomed to starvation. Smaller species, however, could easily survive in tiny patches of land, feeding on whatever they found underfoot. They could hide in burrows, burrow into deep crevices, and build nests in secluded corners where destruction hadn't fully reached. When the so-called impact winter arrived, plunging the world into cold and darkness, such shelters became veritable arks of salvation. The enormous Tyrannosaurus rex couldn't burrow into the ground to escape the freezing cold or the suffocating ashen shroud. This omnivorous diet allowed them to survive where larger, more finicky species were doomed. One such all-rounder could feed on virtually anything edible, including even decaying remains. Meanwhile, a giant herbivorous dinosaur could starve to death in the middle of a devastated forest full of food that was either too small or too hard for it to eat. It's also important to imagine the climate that followed the impact. The skies filled with ash and dust, blocking out sunlight for months, perhaps even years. The planet began to cool, plants died, and entire ecosystems collapsed. The massive bodies of large dinosaurs required a constant supply of calories simply to maintain their temperature. Smaller animals, though vulnerable to the cold, had the ability to conserve energy by entering a state similar to deep hibernation. They slowed their metabolism and hid in shelters to survive the freezing temperatures. Scientists believed that feathered dinosaurs could fluff up their feathers, creating a layer of air to conserve heat. This ability, coupled with their size, gave them a real chance of surviving the long, dark winter. Water became another resource. After the asteroid impact, deadly acid rain poured from the sky. Lakes and rivers became toxic, and finding clean drinking water became a real challenge. Large dinosaurs required enormous volumes of water daily, but smaller reptiles could survive by obtaining moisture from the most unexpected sources. They gave birth to live young rather than laying eggs, which were completely defenseless against predators and the vagaries of nature. Moreover, mammals nursed their young with milk, a unique adaptation that gave newborns a huge chance of survival in their first, most vulnerable days of life. This meant that even in the harshest conditions, their species had every chance of surviving and procreating. Instead of relying on quantity, laying hundreds of eggs in the hope that at least one would survive, they focused on quality. Over millions of years, these unique features allowed mammals to evolve into an incredible variety of forms. Some returned to the ocean, becoming whales and dolphins. Others conquered the skies, becoming bats. Still others spread across the land, taking on forms ranging from giant elephants to agile primates. All this diversity was only possible because their distant ancestors survived the asteroid impact, filling the void left by the dinosaurs. However, it's important to remember that not all dinosaurs died out. The birds we see today are the direct descendants of small feathered dinosaurs that survived the catastrophe. They, too, benefited from their small size, adaptability, flexibility, and varied diet. In essence, the world we live in is not simply the age of mammals. It is the co-reign of mammals and birds, two groups that rose from the ashes of the great dying. The entire land was covered in a thick shroud of ash, and riverbeds were littered with debris and rotting flesh. For the colossal dinosaurs, the rulers of this planet, such total destruction meant the inevitable end. Their era was over. However, for creatures of much more modest stature, this horrific scene of total death was, oddly enough, the beginning of a new life. It was a veritable feast amidst the ruins. They could fearlessly scavenge among the remains of fallen giants, gnawing on the bones left behind by the titans. They could hunt the myriad insects drawn by the scent of decay or seek out surviving seeds buried beneath layers of ash and debris. A world that had become a dead desert for the giants became an endless source of sustenance for these small scavengers and gatherers. a catastrophe of such magnitude which punished the strong and powerful, paradoxically gave a chance to live to the weak and unnoticed. It was the survival of these tiny creatures that ultimately determined the future development of life on the planet. Over time, a whole series of small feathered dinosaurs came to the fore. These creatures, having learned to fly, not only survived the catastrophe, but also flourished to incredible heights. They rapidly spread across the globe, occupying empty ecological niches. Ultimately, it was their evolution that led to the emergence of the birds we see today. Consider this: every common sparrow, eagle soaring in the sky, or urban pigeon is a living reminder of those small but resilient dinosaurs that managed to survive the end of the world. If these giant lizards had somehow managed to continue their lineage, perhaps the avian world as we know it would never have emerged. Thus, the fall of the titans became a powerful stimulus for the evolution of miniature life forms. This ancient story teaches us a crucial lesson about the nature of survival. While incredible strength and gigantic size may inspire awe, they are far from always a guarantee of long-term success. Enormous predators and massive herbivores seemed utterly invincible in their era, but when the world around them changed beyond recognition, they lacked the flexibility to find new paths. But those small, almost forgotten creatures, those who could make do with little and adapt to the most difficult challenges, they turned out to be the true champions of this deadly game. Incredible resilience was the key to the survival of small dinosaurs. It wasn't their strength, but their remarkable adaptability, their ability to find new food sources and new ways of living. That was the key to their triumph. And perhaps even intelligence played a significant role in this process. Smaller dinosaurs, especially those closer to birds on the evolutionary ladder, often had brains proportionally larger relative to their body size. This endowed them with greater curiosity, flexible thinking, and the ability to find innovative solutions in a world that was collapsing before their eyes. Some of them likely discovered new methods of foraging, perhaps even used primitive tools like sticks to dig out grubs, or learned to build their nests in more protected and secure locations. Although we lack direct evidence, it's safe to assume that the mind's ability to adapt was no less important for survival than the body's ability to physically change. Let's imagine this striking contrast. Imagine a massive tyrannosaur, the very same Tyrannosaurus rex. Its massive, multi-ton body trudges through a dead, scorched forest. It roars, but this roar no longer conveys the fury of a predator, but the desperation of a starving animal unable to find prey large enough to feed itself. Now imagine a different scene. A small feathered dinosaur, no larger than a modern crow, nimbly leaps among charred branches. It catches surviving insects, pecks out hidden seeds, hides from danger in narrow crevices, and lays its eggs in secluded, well-camouflaged nests. While the giant who once ruled this land undisputed is doomed to starve to death within weeks, this tiny, almost invisible creature continues its lineage, generation after generation. And so it will continue until its descendants become the new masters, the masters of the heavens. The asteroid impact was a sudden, incredibly powerful, and truly global event. But in many ways, For the planet, it was just another brutal test of survival, one of many that Earth has faced throughout its long history. Consider the monstrous volcanic eruptions, the global ice ages, the slow but inexorable movement of continents, and after each catastrophe, the survivors weren't always the ones you'd bet on. The story of the small dinosaurs is one of the most striking examples of this harsh truth. By the time the Earth began to slowly heal from its wounds, when forests teeming with life once again replaced the parched deserts, when lush vegetation resumed and the climate stabilized, the great age of dinosaurs had already come to an irrevocable end. However, those tiny creatures, especially those that had managed to rise into the sky, were still there. They became the seeds of new life, laying the foundation for the future world. Their descendants filled the skies with their song and hubbub. The wings that became their salvation allowed them to reach the most remote and isolated corners of the planet. Today, their diversity numbers in the tens of thousands of species, and they inhabit every continent, from the icy fields of Antarctica to the scorching sands of the deserts. The legacy of survival belongs not to the fallen giants, but to those small and resilient creatures who persevered in this merciless struggle for existence. Approximately 66 million years ago, an asteroid impact marked the end of the age of dinosaurs. This event wiped out nearly everything large, strong, and dominant on Earth. However, some small and incredibly adaptable creatures managed to find their way to salvation. Among these lucky ones were the ancestors of modern birds, the only direct descendants of dinosaurs still living among us. To truly understand why birds were the surviving dinosaurs, we need to travel back in time and trace their remarkable evolution over millions of years. We'll see how unique traits like feathers, hollow and lightweight bones, and a keen intelligence allowed them to perpetuate their lineage when countless other species were lost forever. This process began long before the fateful asteroid collision that caused the global catastrophe. Some dinosaurs had already begun to change, acquiring traits that gave them completely unexpected advantages. They weren't giants, but their adaptability prepared them to survive in the most challenging environments. Among the large group of theropods, which includes predators like Tyrannosaurus rex, and among its smaller members, several particularly interesting creatures stand out. Theropods were bipedal predators, and it was from their ranks that such famous hunters as Velociraptor and, of course, the enormous Tyrannosaurus rex emerged. However, not all theropods relied on brute strength and lethal force. Some took a different evolutionary path, becoming small, agile, and curious. They developed feathers, which likely initially served to conserve heat, attract mates during mating displays, and perhaps aid in gliding while jumping from branch to branch. Over time, these feathers became one of the most important adaptations, laying the foundation for a true bird flight. The earliest creatures that could even be loosely called bird-like appeared in the Jurassic period, over 150 million years ago. The most famous of these is undoubtedly Archaeopteryx, whose remains were found in limestone deposits in what is now Germany. Archaeopteryx still had teeth in its beak, sharp claws on its wings, and a long, bony tail like a reptile. All these features clearly made it look like a dinosaur. However, it already had true flight feathers. almost identical in structure to those of modern birds. This suggests that it could glide from high above or perhaps even make short flights. Archaeopteryx is a magnificent example of evolution in action. This creature is a perfect transitional link between dinosaurs and birds, not being fully either, but combining key features of both. Its existence clearly demonstrates that the boundary between these two groups was not clear and sharp, but represented a long process of gradual, millions-of-year changes. Millions of years later, a vast array of bird-like dinosaurs appeared on the planet. They were small, light, and very diverse. Some lived in trees, while others sprinted quickly across the ground. These creatures already possessed beaks instead of toothed jaws. Their bones became hollow, making their skeletons incredibly light, and their wings strong enough to glide on air currents. While giant dinosaurs dominated the land, these small feathered creatures occupied their own ecological niches. They lived in a world where speed, agility, and intelligence were valued far more than brute strength. It's easy to imagine them gliding swiftly through prehistoric forests, pecking insects from tree bark, or swooping from branch to branch, while somewhere below, the ground trembled beneath the multi-ton feet of their gigantic relatives. But 66 million years ago, this world changed overnight. An asteroid slammed into Earth. Firestorms engulfed entire continents. Tsunamis hundreds of meters high inundated coastal areas, and thick clouds of dust and ash rose into the atmosphere, blocking out the sun for months, perhaps even years. Without sunlight, plants couldn't photosynthesize and began to die en masse. Food chains collapsed like a house of cards. The herbivorous dinosaurs began to die out en masse, soon followed by the predators that preyed on them. Almost every large creature on the planet disappeared. It seemed as if the age of reptiles had ended forever. But some small dinosaurs did survive, and among them were those that gave rise to the birds we know today. Why did these small feathered creatures survive what destroyed the titans? How did they persevere where millions of others fell? The answer lies in three key factors: their size, their diet, and their incredible adaptability. Small organisms require much less food to survive. Many early birds were able to feed on seeds, insects, and other readily available foods, which remained abundant even in the harshest conditions after the asteroid impact. Seeds hidden in the ground or preserved in shelters could have remained edible for a very long time, even after all the leaves and fruits had disappeared. Insects also survived the disaster much more easily than larger animals, and birds that knew how to hunt them had a virtually inexhaustible source of protein. In a sense, the catastrophe that ended the age of dinosaurs gave insects and their prey even more food than ever before, as they could now feast on the rotting remains of giants. While mighty hunters starved to death, small, agile insect eaters thrived. In a world engulfed in famine and death, some didn't just survive, they feasted. Let's travel to the site of the giant's demise and look at the tiniest victors of this catastrophe. Take, for example, the common fly. Millions of years before the advent of humanity, they honed one instinct to perfection, finding dead flesh and turning it into a cradle for their offspring. No sooner had the enormous animal breathed its last than, within hours, entire swarms would flock to the scent of death. They would settle on the cooling body and lay myriads of eggs, which would soon hatch into hordes of voracious larvae. Each larva was like a tiny biological machine, programmed to do one thing: devour flesh, inexorably and rapidly dismantling what had recently been alive. After the asteroid impact, the entire planet turned into one gigantic graveyard. Dinosaur carcasses littered the ground as far as the eye could see. For flies, it was a veritable golden age. Their population must have exploded, reaching unimaginable proportions. They turned the great destruction into a great feast for their children. Each fallen giant, be it a mighty Triceratops or a colossal sauropod, became a breeding ground for millions upon millions of larvae. But it wasn't just the flies who celebrated their triumph. Beetles also got their chance. Many of them had specialized for centuries in processing dead wood. And then, after a firestorm swept across the planet, prehistoric forests were transformed into endless piles of charred fallen trunks. Termites and wood-boring beetles became indispensable caretakers of the ecosystem, gnawing into the dead trees and beginning the long process of their decomposition. Other beetle species also emerged, feeding on the remains of the larval bodies or processing dung and other waste. Given the colossal number of animals that perished, the earth provided them with an inexhaustible source of food. But it was mammals that became the dominant force on land, shaping ecosystems and ultimately paving the way for the emergence of humanity itself in the distant future. Fast forward 10 million years after the asteroid impact. Earth is already unrecognizable. It is filled with amazing creatures, most of them unfamiliar to us, but all of them are mammals. Herbivores the size of enormous cows graze in the forests, followed closely by wolf-like predators. Herds of early ungulates roam the vast plains, grazing on the grass that is only just beginning to conquer the planet. The first bizarre saber-toothed predators appear, harbingers of the fearsome cats of future eras, and monkeys and early primates are already climbing the trees, standing at the very beginning of the long journey that will one day lead to the emergence of humans. This world no longer belongs to dinosaurs. It is now ruled by the descendants of those tiny, inconspicuous creatures that lurked in the shadows of giants for millions of years. The rise of mammals changed the very structure of ecosystems. Previously, dinosaurs dominated through brute strength and gigantic size. Mammals, however, brought something new to the world: complexity and flexibility. Their ability to adapt to a wide variety of conditions created complex networks of relationships unimaginable in the previous world. Mammals became herbivores, predators, scavengers, tree climbers, swimmers, and flyers. Beetles, renowned for their incredible resilience, were perfectly adapted to the harsh conditions of the New World. They could burrow deep into the earth or hide under thick tree bark, escaping the cold and eternal darkness, while above ground they methodically consumed the remnants of the bygone era. Ants, another remarkable group of insects, also demonstrated incredible adaptability. Their strength lay in their unity. These social creatures acted as a single organism, organizing entire colonies to search for and gather food. Foraging ants tore tiny fragments from enormous carcasses and carried them to their underground cities to feed the queen and the rising generation. A single ant was weak and insignificant, but thousands of tiny jaws working together could strip a skeleton clean. and their deep underground tunnels provided them with a safe haven from fire, freezing cold, and the few remaining predators. While the world above burned and froze, the ants below quietly continued their work. And, of course, cockroaches, which many today detest, proved to be among the most resilient survivors of those dark times. Their secret lay in their astonishing omnivorousness, the ability to convert virtually anything, from rotting wood to scraps of flesh, into food, made them versatile soldiers of the apocalypse. In a devastated world, these creatures turned to nothing. After the asteroid impact, they crawled among the ruins, devouring everything in their path. Their flattened frame allowed them to squeeze into the tiniest crevices, and the durable cocoons in which they stored their eggs reliably protected their future offspring. All this allowed them to thrive and reproduce, while larger, more specialized creatures died out en masse. However, the role of these insects was far more important than simply providing sustenance. By devouring the remains, they performed a titanic task, clearing the planet for new life. Imagine this nightmarish landscape. If every dinosaur perished after the impact had remained on the ground, the world would have drowned in decay. The stench of decomposition and toxic fumes would have made survival impossible for even the most resilient. But instead, insects acted as tireless scavengers of the planet. They processed trillions of tons of dead organic matter, converting it into nutrients for the soil. And when sunlight finally broke through the veil of dust, this soil was ready to give birth to new plants. Without insects, the Earth's restoration would have taken hundreds, perhaps thousands of years longer. Insects also played a key role in the fate of other survivors. Small mammals, our distant ancestors, hid in burrows and crevices, desperately clung to life. Vegetation died, seeds became incredibly rare, and hunting large prey was deadly. And so, many of these animals switched to a new abundant food source: insects. Beetles, termites, fat larvae, and ants became their true salvation. Thus, the explosive growth of insect populations after the catastrophe not only helped mammals survive the darkest hour, but also allowed them to gradually occupy the vacated ecological niches. It is no exaggeration to say that without these tiny creatures who sustained life in the ruins, the path that ultimately led to the emergence of humans might never have begun. This great recycling process can be imagined as a conveyor belt of death and rebirth. A huge dinosaur falls to the ground, slain by fire, cold, or starvation. Flies are the first to feast. They lay eggs, and soon hordes of larvae are gnawing at the soft tissue. Then comes the turn of beetles, termites, and other specialists, who finish off what remains. Thus begins the endless cycle of life and death. Next, work begins on more complex areas. Ants carry small debris back to their colonies. Termites toil over fallen trees, and cockroaches scurry everywhere, scavenging for even the smallest crumbs. Meanwhile, the remains slowly decompose, fertilizing the soil, and surviving mammals, birds, and reptiles happily hunt the insects themselves, adding new links to this fragile food chain. Gradually, the earth is cleansed, and the cycle is ready to begin again as soon as the next dead body falls. The insect world often escapes our attention, but after the asteroid impact, it became one of the main engines supporting life on the planet. Their ability to recycle waste and feed on what others left behind made them the silent heroes of survival. Mighty dinosaurs, with their monstrous teeth and sharp claws, proved powerless against global catastrophe. But insects, armed only with tiny jaws and endless patience, survived. Even in hell, they simply kept doing their job. A similar picture unfolded along ocean coastlines and riverbanks. When the shock wave and tsunami washed millions of tons of dead fish and marine reptiles onto land, local insect scavengers immediately sprang into action. In the deep sea, crustaceans and worms performed this work, but on land, it was insects that served as the primary cleanup crew. Their sheer numbers gave them a colossal advantage. A single female fly can lay hundreds of eggs, and a queen ant can produce thousands of workers. Cockroaches and beetles reproduced at an equally rapid rate. This meant that even if a catastrophe wiped out a huge portion of their population, there would be enough survivors to quickly replenish their numbers. In a world where most species desperately struggled to survive, insects simply multiplied and conquered the planet. The asteroid collision clearly demonstrated that size and strength don't always guarantee victory. Flexibility, numbers, and the ability to adapt proved far more important, and insects possessed all of these qualities in abundance. They could survive in tiny spaces, didn't need much food at a time, and were able to hide quickly. Furthermore, they weren't tied to a single diet. They could eat wood, leaves, meat, dung, even each other. This flexibility allowed them to turn the greatest catastrophe in Earth's history into an opportunity for prosperity. When we recall those times, our gaze is usually drawn to the tragic demise of the dinosaurs, the true titans of the ancient world. But a closer look reveals that the true triumphs of that dark era were the smallest creatures, the buzzing of flies, the clicking of beetles, the marching columns of ants, and the scurrying of cockroaches. These are the sounds that filled the world after the deafening roar that once shook the prehistoric forests died down. Time passed. The sky gradually cleared and the saving sunlight returned to the earth. Plants began to grow again. The soil, freed from the oppression of giant animals and generously fertilized by the labors of insects, became an ideal environment for new life. Forests and meadows began to revive. Insects not only continued their sanitary work, but also returned to their usual activities, pollinating the first flowers and feeding on fresh leaves. The balance of life had changed forever, but insects remained at its center. Their unseen work paved the way for everything that would come next. It's strange to realize that the future of the planet, including the emergence and rise of mammals and later humans themselves, depended so heavily on tiny creatures like flies and ants. But it's an undeniable fact. If insects hadn't cleaned the world after the asteroid impact, Earth could have turned into a toxic, rotting desert. And without them, our tiny ancestors likely never would have had a chance. To understand why freshwater ecosystems became veritable arcs of life, one must imagine the full horror that unfolded on the planet after the impact. The explosion itself, whose epicenter was located in what is now Mexico's Yucatan Peninsula, unleashed unimaginable energy. Earthquakes convulsed the earth. Volcanoes erupted across the planet, and skyscraper-sized tsunamis swept along the coasts. Billions of tons of dust, rocks, and droplets of molten rock soared into the atmosphere. The sky became covered in an impenetrable shroud, obscuring the sun for months, perhaps even years. This global darkness halted photosynthesis. On land, forests and grasslands began to die. For herbivorous dinosaurs, this meant certain starvation. And for the predators that hunted them, their food supply simply disappeared. However, beneath the surface of the lakes and rivers, the picture was different. Algae and hardy aquatic plants continued to thrive here. They had a much better chance of survival, as some could obtain energy from nutrients dissolved in the water, even in very low light. The water itself served as a shield, protecting them from falling ash and maintaining a more stable temperature than in the open air. This also offered a chance for survival for those dinosaurs, whose lives were closely tied to water, especially the smaller and more adaptable species. It was likely these damp, swampy lands that became the last source of food and refuge for the survivors. Imagine riverbanks and flooded lowlands. They were overflowing with rotting organic matter, a veritable feast for microscopic life. In this chaos, insects and small creatures thrived, finding shelter among the debris of fallen forests. For herbivorous dinosaurs, whose usual pastures turned to ash, reeds, ferns, and aquatic plants, became salvation, a meager but vital food at a time when nothing else remained. For carnivorous predators whose vast herds of prey had vanished from the face of the earth, fish and amphibians were their last chance of survival. In an era of monstrous change, any chance of finding something edible became the difference between survival and ultimate extinction. Freshwater bodies became, at least temporarily, a lifeline for anyone who managed to reach them. Equally important was the opportunity to scavenge in these waters. After the asteroid impact, countless creatures perished, their bodies washed into rivers and lakes. At first, insects and fish fed on these remains. Then, larger animals began to hunt these fish and insects. Thus, fragile but genuine food webs were formed that continued to function even in the face of global catastrophe. Dinosaurs capable of hunting near water or not averse to scavenging gained access to this hidden economy of survival. It wasn't a comfortable life, but in those desperate times, it allowed life itself to continue. Another crucial property of freshwater refuges was the protection they provided from the harsh environment. On the open plains, the air was thick with choking dust, and the ground was a scorched wasteland. But water acted as a natural shield. Near lakes and swamps, the climate was cooler and more humid, which protected eggs, plants, and small animals from complete destruction. Dinosaur nests located near swamps may have had a much better chance of survival, especially for those species that already preferred such habitats before the disaster. Crocodiles, turtles, and amphibians survived the Great Dying largely because their lives and reproduction were inextricably linked to water. It's quite possible that dinosaurs living in similar conditions also gained a certain advantage, at least for a time. The fossil record confirms that wetlands were among the last refuges for dinosaurs. Across North America and Asia, the youngest fossils of these reptiles are found in the sediments of ancient rivers and lakes. This suggests that even long after the asteroid impact, when forests and plains had become deserted, some dinosaurs still clung to life near water. Perhaps these were smaller herbivores feeding on aquatic vegetation, or predators stalking fish and amphibians. It's important to remember that not all dinosaurs were giant, earth-shaking monsters. Many species were smaller, lighter, and far better adapted to wet conditions. Some possessed features that made them ideal swamp dwellers: wide feet for walking through sticky mud, or long necks for reaching underwater plants. These creatures likely frequently used rivers even before the catastrophe to find food and escape predators. Rivers and lakes were the natural habitat for these dinosaurs. Their modest size meant they required less food, and their adaptability allowed them to feed on almost anything they could find. These qualities, which helped them survive in normal times, may have given them an additional chance after the global cataclysm. However, even freshwater refuges couldn't protect dinosaurs forever. Global climate change proved too severe and prolonged. As the years passed, even lakes and rivers could no longer provide sufficient resources to support large populations. Ultimately, most species disappeared, unable to cope with the cold, hunger, and toxic environment. Only one small lineage of feathered dinosaurs, known today as birds, managed to survive this apocalypse and find a new world. But in those critical first years after the asteroid impact, freshwater oases were likely the last bastions of their ancient relatives. The fact that rivers and lakes were reliable refuges is confirmed by the examples of other survivors. Take crocodiles, for example. Each new form interacted in its own way with plants, insects, and other animals, creating richer and more balanced ecosystems. In this sense, the arrival of mammals was more than just a replacement for dinosaurs. It was a complete restructuring of the world, the creation of an entirely new reality. And how bittersweet it is to realize that if that asteroid had not fallen to Earth, the age of dinosaurs might have continued to this day. And mammals would likely have remained small, inconspicuous creatures forever. Perhaps elephants, whales, or primates would never have appeared on our planet, and certainly there would be no humans able to look back billions of years and tell this incredible story. The rise of mammals was not predetermined. It was the result of blind chance, a monstrous catastrophe, and an astonishing ability to survive that allowed our ancestors to seize the moment when the great giants fell. And even today we hear the echoes of that ancient turning point. We live in a world born from fire and ashes. Today's world is filled with mammals, from the tiny field mouse to the gigantic blue whale, the largest creature on the planet. You and I also belong to this class, the result of an incredibly long evolutionary journey. This journey began in the shadow of giants, when our tiny rodent-like ancestors managed to survive one of the most terrible catastrophes in Earth's history. Imagine the impenetrable darkness that descended on the planet after the asteroid impact. They lived alongside dinosaurs for millions of years and managed to survive their extinction. Why? Because they were inextricably linked to the aquatic environment, ate almost anything, and could go for months without food. Turtles and amphibians, also inhabitants of wetlands, also survived this ordeal. Fish and many invertebrates simply continued their life cycles underwater. These examples clearly demonstrate what a powerful protection and source of life the aquatic environment was. and the dinosaurs that shared this environment with them likely enjoyed the same advantages, at least for a time. The rise of mammals amid the decline of dinosaurs is one of the most fascinating chapters in the long history of life on Earth. It's a story full of struggle, survival, incredible accidents, and ultimately, triumph. To truly understand and appreciate this event, we need to return to the time when dinosaurs still reigned supreme on our planet, ruling the continents for centuries. This was over 160 million years ago. Mammals were then tiny and inconspicuous creatures, literally hiding in the shadows of these giants. For most of this long era, they existed, but their size, power, and influence were negligible. However, as the age of dinosaurs approached its dramatic end, conditions gradually emerged for mammals to rise, adapt, and ultimately assume a dominant position in the world. This would have been unthinkable when tyrannosaurs and long-necked sauropods roamed the earth freely. This transition was not sudden. It wasn't as if one group fell and another instantly took its place. Instead, it was a complex process, stretching over millions of years. The history of mammals was shaped by a multitude of factors, random events, global climate change, and, of course, the unique ability of these animals to adapt, survive, and explore new niches. When we imagine the world of the late Cretaceous period, some 6 million years ago, we imagine enormous creatures. The mighty Triceratops with its gigantic horns, the fearsome Tyrannosaurus rex with its deadly jaws, and entire herds of duck-billed hadrosaurs. They inhabited forests overgrown with giant ferns and the first flowering plants. But this world also included mammals, only they were nothing like the large animals of today. Most were tiny, the size of a mouse, a shrew, or a small rat. They led a secretive lifestyle hiding under the cover of darkness. Their modest size, of course, limited their capabilities in many ways, but it also gave them unique advantages. While enormous dinosaurs required colossal amounts of food, small mammals could survive on much less. While dinosaurs dominated the daylight, mammals found safety in the night, actively fighting for survival when most predators slept. This lifestyle honed their senses to the extreme, endowing them with acute hearing, a phenomenal sense of smell, and in some cases, even the ability to sense heat in complete darkness. For tens of millions of years, mammals remained small and virtually invisible. They didn't directly compete with dinosaurs for dominance. Instead, they created their own tiny niches in the environment where they could survive without attracting undue attention. Some specialized in eating insects, others on seeds or small plants, and still others on hunting tiny lizards. This modest, almost unnoticed existence allowed them to survive for centuries and significant changes in the world. And now, every time we see a squirrel nimbly hopping along a tree branch, or a domestic cat lazily basking in the sun, or even a baby drinking its mother's milk, it's all an invisible thread connecting us to that distant past, to that turning point when the age of dinosaurs collapsed into oblivion and mammals got their chance to thrive. Let's travel back 66 million years to the very end of the Cretaceous period. When a colossal catastrophe struck Earth, it caught not only the all-powerful dinosaurs, but also the planet's entire ecosystem by surprise. An asteroid the size of a mountain slammed into the surface at incredible speed, and the impact shook the very foundations of the world. The oceans literally boiled, and the sky filled with thick, choking smoke and tons of dust. Firestorms raged across the planet, devouring entire continents. Titanic tsunamis slammed into the coastlines, washing away everything in their path. And then came darkness. For months, perhaps years, a thick curtain of soot and ash in the atmosphere completely blocked out the sunlight. Food chains built over millions of years collapsed overnight. Forests, deprived of light, withered and died. And the great rulers of this planet, the giant dinosaurs who had ruled the world for over 160 million years, vanished forever. Their reign was over. And yet, in this global apocalypse, life did not perish completely. Among those who survived were some of the most ancient and resilient creatures, reptiles and amphibians. Their bodies, their way of life, their survival strategies were forged long before the age of dinosaurs, and they were destined to outlive its end. Let's imagine the scene immediately after the impact. The force of the asteroid's impact was equivalent to the detonation of billions of atomic bombs. The shock wave from this cataclysm circled the globe many times over. Any living creature near the epicenter had no chance of survival, but those that survived typically led a secretive, almost invisible life, deep underwater, buried in mud, protected by rocks, or in deep burrows. Amphibians and reptiles were true masters of this kind of clandestine existence, while dinosaurs reigned above ground, feeding on plants and hunting large prey, resources that vanished almost instantly. These inconspicuous creatures remained in the shadows, clinging to life. These small, unhurried animals had their own secrets, their own strategies, which helped them survive hunger, the eternal cold, and the general chaos. Among them, amphibians such as frogs and salamanders proved particularly fortunate. These creatures appeared on the planet long before the asteroid impact. Their distant ancestors already inhabited bodies of water more than 200 million years ago, as early as the Triassic period. Frogs, with their simple yet incredibly efficient reproductive method, could lay thousands of eggs at a time in freshwater ponds and slow-moving streams. And even though most of these offspring perished in the harsh conditions, it was enough to sustain the species. Their tadpoles fed on microscopic algae and decaying organic matter in the water, resources that remained available even when forests and fields turned into parched deserts. When adult frogs could no longer find insects to feed on land, many simply returned to bodies of water and lay low. Some species possessed the astonishing ability to enter a state of suspended animation, burrowing deep into the mud and virtually halting all vital processes. Their heartbeats slowed to a barely perceptible tremor. They could remain in this state for months, waiting for conditions above ground to improve. This incredible ability to literally pause life allowed frogs to survive the darkest days in the planet's history. Salamanders, with their lithe, elongated bodies and secretive lifestyle, also managed to survive this storm. Most spend their lives in moist soil, under rotting logs, or in dark caves. They require very little food to survive and can remain motionless for very long periods. Moreover, some salamander species are able to regenerate lost limbs, a unique skill that gave them a huge advantage in this new perilous world. While the skies were black with ash and soot fell from the sky like black snow, Salamanders quietly waited out the storm, using the soil moisture to protect against fires and drought. Unlike dinosaurs, which needed vast territories and a constant food source, salamanders could exist unnoticed in their small, secluded worlds. A desperate struggle for survival raged across every corner of the earth. Among reptiles, turtles stand out, creatures that seem to have changed little since time immemorial. By the time the asteroid struck, they had already existed on the planet for over 200 million years. Their bodies, encased in a tough shell, are like living fortresses, protecting them from countless threats. However, their survival was not solely due to their armor. Turtles are true champions of patience. They can slow their metabolism to such an extent that they can go months without food. Some aquatic species can even survive without air, diving into frigid water and remaining there for hours. When an asteroid blocked sunlight and the planet's temperature plummeted, turtles found refuge in lakes, rivers, and the seabed. Burrowing into the mud or simply lying on the bottom of a body of water, they could breathe through their skin or special folds in their cloaca, surviving where many other creatures suffocated or died of hunger and cold. The world around them might have collapsed, but turtles remained calm and unperturbed, simply biding their time until the earth began to heal. Crocodiles, ancient relatives of modern alligators, were also among the survivors. These reptiles were formidable predators even during the time of the dinosaurs. But it wasn't brute strength that saved them, but their amazing ability to adapt. Crocodiles are ambush hunters, capable of going incredibly long periods without food. They can go months without eating, relying on accumulated fat reserves and their extremely slow metabolism. They spend most of their time in the water, drifting motionless near the surface and waiting for prey to come close. When disaster struck and their usual prey disappeared, they didn't starve. They simply expanded their menu, feeding on whatever they could catch: fish, shellfish, carrion, small reptiles, and even unwary mammals. Like turtles, crocodiles benefited from their aquatic lifestyle. Water protected them from firestorms, cold, and darkness, giving them time to adapt to a new hostile world. Their survival story is a clear example that sometimes patience and conservation of energy can be far more effective than speed and power. Snakes are another remarkable master of survival. These legless reptiles were already fully colonizing the planet by the end of the Cretaceous period. More than 66 million years ago, our planet looked completely different. Colossal creatures tramped its surface, their presence felt in every forest, every swamp, every riverbank, and across the endless plains. Dinosaurs weren't just part of the fauna. They were the absolute rulers of the land, the seas, and even the air. These wondrous creatures flourished for over 160 million years, their evolution giving rise to countless shapes and sizes. Among them were true giants, as tall as multi-story buildings, and at the same time, small and agile predators that darted between the trees. Others glided through the skies on enormous leathery wings. Earth was their empire, and it seemed nothing could ever challenge their dominance. But the universe had other plans. High above the planet, in the silent dark void of space, far from warm sunlit lands, a gigantic rock was hurtling toward our world. It wasn't just any rock. It was an asteroid tens of kilometers across, hurtling at a speed unimaginable. Imagine a mountain moving faster than a bullet. For millions of years, this space wanderer wandered the solar system until the invisible hand of gravity grabbed it and pulled it toward Earth. At that very moment, the fate of the dinosaurs and the entire course of evolution on the planet teetered on the brink of the abyss. On the day the asteroid collided with Earth, the planet shook to its very core. Snakes have a unique ability. They swallow their prey whole and then rest for weeks, even months, while the food is slowly digested. In times of famine, this skill is invaluable. Many snakes lead an underground lifestyle, hiding in burrows or deep crevices, which served as a reliable refuge during the most difficult times after the asteroid impact. Fossil evidence shows that after the extinction of the dinosaurs, snakes adapted incredibly quickly to the changing world, occupying vacant ecological niches. The disappearance of large predators gave them the green light to thrive. They began to rapidly spread and evolving into the thousands of species we know today. The secret to their success lay not only in a flexible diet, but also in their ability to hide, live unnoticed, and patiently bide their time. Lizards, lesser-known species, also survived the apocalypse. Small species could feed on anything: insects, plant debris, or any carrion they came across. Their small size meant they required very little energy, and they escaped danger by hiding in the smallest cracks in the ground or under rocks. Of course, during the global winter, when plants died and insects became extremely scarce, lizards had a hard time. But their high reproductive rate and ability to exist in tiny, isolated shelters helped them persevere. Some species, such as geckos, could escape above-ground threats by clinging to sheer cliffs or hiding in caves. These strategies allowed lizards to survive the catastrophe, although many species undoubtedly shared the fate of the dinosaurs. We mustn't forget the role of ecosystems themselves in this story of survival. While dinosaurs depended entirely on green forests and vast plains, many reptiles and amphibians were closely associated with freshwater habitats: ponds, rivers, lakes, and swamps. These places, though devastated by the catastrophe, became veritable arcs of life. Water protected from fire, moderated sudden temperature fluctuations, and served as the basis for an alternative food chain built on algae and decaying organic matter. Amphibians laid their eggs in the water, reptiles hunted in rivers or burrowed into the muddy bottom. Even snakes and lizards found refuge in the damp thickets near the water. These freshwater oases became the last refuges when the land turned into a lifeless, ash-filled desert. And finally, most importantly, the very physiology of reptiles and amphibians was perfectly adapted for survival in such harsh conditions. Unlike dinosaurs, which many scientists now believe were warm-blooded or partially warm-blooded, reptiles and amphibians are cold-blooded. Their body temperature depends on the environment, meaning they require much less energy to sustain life. In a world where food was extremely scarce, this characteristic proved their greatest asset. In a world where every calorie was precious, these giants found themselves in a deadly trap. A huge dinosaur could starve to death in a matter of days, weeks at most. Meanwhile, turtles, snakes, and crocodiles mastered the art of waiting, allowing them to go months without food, entering a state akin to suspended animation. Let's transport ourselves to that nightmarish world immediately after the impact. Imagine this apocalyptic landscape. Forests, once teeming with life, were now endless fields of charred tree trunks. Rivers carried tons of ash, and their banks were strewn with the bodies of dead creatures. Here we see a gigantic dinosaur, exhausted beyond measure, no longer able to hunt or even scavenge. It sank heavily to the ground, never to rise again. But just a few steps away, in a silted pond, a turtle lies motionless. Its heartbeat slows ever slower, plunging it into a deep hibernation. It simply waits for this distraught world to find peace again. A crocodile drifts silently through the murky water, the very embodiment of patience. It stores up its energy for a single, lightning-fast strike, ready to latch onto any fish or small animal that makes a mistake and moves. Somewhere in a rock crevice, the snake coils itself into a tight knot, its metabolism slowing almost to a standstill, reducing its bodily needs to an absolute minimum. A frog instinctively burrows into the damp earth, creating a shelter until the first saving rains fall on the parched land. This is a survival scenario in which there is no room for resounding victories or heroic battles. Here, patience, silence, and the masterful art of waiting reigned supreme. Centuries passed, and when the sky finally began to clear and the first shoots broke through the ashes, these masters of survival returned. The swamps once again filled with the deafening chorus of frogs. Turtles slowly crawled ashore, exposing their shells to the rays of the reborn sun. Snakes slid silently through the young grass in search of prey, and crocodiles once again became the undisputed masters of the rivers. They didn't just survive, they returned to become part of a new nature and lay the foundation for an entirely different world. The extinction of the dinosaurs left a vast void on the planet. Reptiles and amphibians, though they didn't ascend to the throne of apex predators, continued their ancient ways, adapting to the changing climate and landscapes. They didn't need to replace the titans of the past. Mammals would soon take over that role. Instead, they remained silent but incredibly resilient witnesses to the greatest changes in Earth's history. The fate of these creatures teaches us an important lesson about the very essence of life. It turns out that brute strength and colossal size are not always the key to success. Sometimes it's flexibility, patience, and the ability to lie low and wait out the storm that make all the difference. Dinosaurs were the undisputed rulers of their era, but when the world changed too drastically, their greatness became their greatest weakness. But reptiles and amphibians, these creatures of shadow and water, carried within them an ancient wisdom written into their very nature, a wisdom that allowed them to survive the darkest night in the history of the planet. Over the next millions of years, the surviving species began to thrive. Frog and salamander populations exploded, inhabiting ponds, forests, and mountain streams. Turtles continued their leisurely march through time. Some colonized rivers, others returned to the oceans, their tough shells protecting them as reliably as they had during the Great Catastrophe. Crocodiles and alligators evolved into the mighty river hunters we know today, descendants of those who were once prey. Hiding in the shadows of dinosaurs, they bided their time. The snake lineage exploded in a variety of shapes and sizes. From tiny blind snakes that spent their entire lives underground to giant pythons capable of swallowing a whole deer, they found their way into this new world. Lizards adapted to life in deserts, jungles, and even near human settlements. All of them are a living reminder of the day when the world stood on the brink of total annihilation, but life, against all odds, found a way to continue on. Life on our planet has always relied on the delicate balance of its ecosystems, and when this balance is disrupted by a global cataclysm, the world requires unimaginable effort and time to regain equilibrium. The recovery of nature after the extinction of the dinosaurs is one of the most astonishing chapters in the Earth's history, demonstrating the almost mystical resilience and vitality of life itself. After the asteroid impact, the world lay in ruins. Vegetation perished due to the eternal night that shrouded the planet. Food chains were torn to shreds, and the great lizards that had ruled here for millions of years vanished forever. It might have seemed as if life had died out completely. In the first millennia after the catastrophe, the planet was a quiet, barren, and alien place, but slowly, very slowly, life began to return. Insects crawled from the ground, small mouse-like mammals prowled the twilight, searching for seeds or those same insects, and some pioneer plants adapted to rapid growth to fill the void left by the giants of the past. Even in the dim light barely penetrating the dust, these tiny sparks of life became the foundation for entirely new ecosystems. At first, the recovery was uneven. In some regions, such as coastal zones and marshes, life returned more quickly. Water became a cradle for surviving plants and small creatures. Meanwhile, in the arid interiors of the continents, ecosystems took much longer to recover. It's important to understand that an ecosystem isn't just a collection of living things living side by side. It's an incredibly complex mechanism where plants provide food and shelter for herbivores. Predators control herbivore populations, and scavengers return dead organic matter to the soil, completing the cycle. For this system to function again, all its elements had to return to their proper places and begin to interact harmoniously. This didn't take years or centuries. It took millions of years. In the early stages, plants played a key role. Without them, there would have been no herbivores, meaning there would have been nothing for predators to hunt. Firestorms after the asteroid impact destroyed most of the forests, and the subsequent sharp cold snap hindered the growth of new trees for a long time. The very first plants to return to the parched land were incredibly hardy species, able to survive in poor soil and with minimal light. These were ferns and low-growing shrubs. They became pioneers, the first green soldiers to brave the darkness and cold. Once these pioneering plants covered the landscape, conditions became more favorable for other, larger species. They provided shade, retained moisture, and provided a home and food source for insects and small animals. This gradual return of greenery marked the first steps toward the planet's restoration. Over time, as the skies cleared and the sun shone again in full force, forests began to regenerate. At first, these were not the dense jungles of the Mesozoic era, but rather scattered groves and copses. But even these became a refuge for countless insects, birds, and the first mammals. Insects were especially important during this stage. They pollinated plants, processed dead wood, and served as a vital source of protein for other creatures. Without this army of tiny workers, the restoration of life on Earth might have taken even longer or perhaps never occurred. The history of the ocean's recovery followed its own, no less dramatic path. They too went through a long process of healing. The asteroid impact triggered monstrous tsunamis, and acid rain descended on the surface, destroying marine food chains. Many giant marine reptiles that dominated the oceans vanished without a trace. Plankton, the microscopic basis of all ocean life, also found itself on the brink of extinction as sunlight ceased to penetrate the deep waters. However, as soon as the atmosphere cleared, plankton populations began to rapidly recover. As soon as they returned, food became available for small fish, followed by larger predators. Coral reefs, severely damaged by the changing water chemistry, also began to slowly regrow. This was one of the longest processes, as reefs are entire underwater cities supporting thousands of species. Their recovery took millions of years, but with their return, the oceans once again teemed with life. On land, the story of recovery was written by mammals. In the age of dinosaurs, they were tiny, inconspicuous creatures living in the shadow of giants. But their small size became their greatest asset in the New World. They could hide in burrows, feed on a wide variety of foods, from insects to roots, and reproduced much faster than the giant reptiles. As ecosystems recovered, mammals began to fill the vacant roles. Some became swift hunters, others peaceful herbivores. Still others adapted to life in the trees. This slow but steady spread of mammals across the planet ultimately paved the way for the emergence of primates and, millions of years later, humans. But in the first epochs after the asteroid impact, they were still small and modest. They were simply survivors who seized the opportunity presented to them by the great catastrophe. However, this renaissance was not smooth and trouble-free. It was full of setbacks, and new challenges. Volcanic activity still raged across the planet, changing the climate and landscape. Continental movement and rising sea levels inundated some coastlines and exposed others. Each such change forced young ecosystems to adapt anew, and sometimes completely destroyed them, forcing life to start over. Scientists studying the fossil record of that period see a complex and intricate picture, far from a simple, linear recovery. Contrary to our beliefs, life did not return to the planet in a triumphant march. It was not a sudden rebirth. Imagine the vast ash heap left by a colossal forest fire engulfing an entire continent. That's exactly what Earth looked like. Recovery proceeded agonizingly slowly, in isolated bursts, followed by long periods of calm. Million years after million years, like a stubborn sprout breaking through scorched soil, the biosphere stubbornly regained its lost positions. And the most astonishing thing about this long, drawn-out process is that the world that emerged from the ashes was completely different from the one that perished in the fire. Entirely new ecosystems arose on the ruins of the old order, radically different from anything that had existed during the reign of the dinosaurs. Let's fast forward to those distant times. Before the impact from the sky, the landscape was dominated by giant reptiles. Incredible sauropods and herds of hadrosaurs were the primary consumers of vegetation in the vast forests dominated by conifers and ancient cycads. But now these titans have faded into oblivion. Their place, once seemingly unshakable, has gradually begun to be taken by mammals. Instead of the roar of multi-ton herds of dinosaurs, the world began to listen to the soft hoofbeats of early ungulates, the first ungulates, grazing among flowering plants. These flowering plants, which had emerged in the twilight of the dinosaur era, now had their greatest opportunity. Freed from the constant oppression of giant herbivores that devoured everything in their path, they began to actively expand. It was then that endless grasslands began to appear on the planet, an ecosystem that had previously been a true rarity. The moment of impact was so monstrous that it released energy millions of times greater than all nuclear weapons ever created by humans. The spacecraft smashed into what we now know as Mexico's Yucatan Peninsula, leaving a gigantic scar on the face of the planet. This crater, known as Chicxulub, remains hidden to this day beneath a layer of rock and sediment. The impact generated a blinding flash of heat that instantly vaporized rock and ignited forests for thousands of kilometers around. In the following seconds, waves of fire and molten rock erupted from the epicenter, incinerating all life in their path. Dinosaurs, unfortunate enough to be nearby, didn't stand a chance. They vanished in a split second, swept away by a hellish blaze the likes of which this world had never seen. But this was only the beginning of the catastrophe. The asteroid impact generated seismic waves that caused the Earth's crust to vibrate like a giant drum. Incredible tsunamis, their crests towering over modern skyscrapers, roared across ancient oceans, crashing onto shores and inundating vast tracts of land. Volcanoes erupted in the most remote corners of the planet, spewing columns of ash and streams of lava into the sky, as if the Earth itself were writhing in its death throes. The sky above became a battlefield. Debris falling from orbit and red-hot fragments from the asteroid rained down on continents, sparking wildfires that spread with the fury of a hurricane. These new sun-drenched spaces, covered in a carpet of grasses, became home to countless new life forms. And the chief architects of this new world were birds. Having survived the great catastrophe, they proved to be a living bridge linking the ancient world with the future. Many of the first avian survivors were small and fed primarily on insects. But over time, their diversity began to astound. Some mastered hunting fish in rivers and lakes, others developed a passion for juicy fruits, and still others, unwittingly, took on the role of gardeners of the planet. By eating fruit and carrying seeds over vast distances, birds helped forests reclaim new territory. Their ability to fly made them harbingers of life in a devastated world. But the speed of this revival was deceptive. It only demonstrates how fragile and complex the web of life is. For us humans, whose lives are but a fleeting moment, these numbers seem astronomical. Just consider this. In some places, fossils show almost 1 million years passed before large animals dared to return to the devastated lands in any significant numbers. In other regions, it took 2 or even 3 million years for complex forests to form. When we talk about millions of years, the imagination struggles to grasp the scale. Our lives seem like a speck of dust compared to eternity. However, for Earth itself, such time frames are commonplace. Life is in no hurry. It patiently, step by step, mends its wounds until the delicate balance is restored. And as soon as ecosystems began to recover, evolution kicked into high gear, opening up new, exciting directions. The extinction of the dinosaurs left a colossal vacuum in nature. Numerous ecological roles became vacant, and so the survivors, mammals, birds, and reptiles, entered the race to fill these roles. They began to rapidly change, giving rise to new, astonishing forms. Some mammals followed the path of gigantism, growing ever larger and switching to foraging in open spaces. Others developed razor-sharp teeth and deadly claws to ascend to the throne of apex predators. Birds, too, experienced an explosion of evolutionary diversity, giving rise to thousands of forms, from tiny hummingbird-like creatures to mighty, flightless giants that came to dominate entire regions. Evolution is a great artist, painting its masterpieces on the canvas of life. But for this to happen, the canvas, the ecosystem itself, must be ready. And the world's slow recovery after the mass extinction gave evolution the very chance to create previously unseen patterns of life. One of the most astonishing chapters of this story is the question of how long it took the planet to regain its former biodiversity. Scientists estimate that it took at least 10 million years for global biodiversity, that is, the total number of living species, to fully recover to its pre-asteroid impact level. This means that for nearly 10 million years, Earth lived in the shadow of a great catastrophe. The world slowly, painfully, returned to its former abundance. However, eventually, it not only recovered, but became even more diverse than before. The age of mammals and birds, which succeeded the age of dinosaurs, gave birth to an incredible array of new species, from giant mammoths to swift cheetahs, from colorful parrots to clumsy penguins, and ultimately, it led to the emergence of humans. Over an incredibly long period, stretching over tens of millions of years, one of the most monumental transformations in the history of life occurred: the evolution of birds. This transformation led to the emergence of thousands of species that today fill our skies, forests, deserts, and even oceans around the world. But birds didn't suddenly emerge in their modern forms. Their journey was slow, complex, and filled with dramatic struggles and ingenious evolutionary breakthroughs. To truly understand this incredible diversity, from tiny hummingbirds soaring through the air like helicopters to enormous flightless ostriches racing across the savanna, we must return to their roots, reaching back to the very dawn of the dinosaur era. Let's trace the winding path they took to survive, adapt, and ultimately evolve into the stunning diversity of forms we know today. This story is not simply about wings and feathers. It is a saga of resilience, constant change, and the boundless creativity of evolution itself. The ancestors of modern birds lived alongside dinosaurs in a world that began more than 200 million years ago. Among the giant reptiles of the Triassic and Jurassic periods, one group of small feathered dinosaurs began experimenting with an entirely new way of life. These early creatures, which looked far more like feathered lizards than the sparrows we are accustomed to, took their first tentative steps toward becoming birds. One of the earliest and most astonishing of these was Archaeopteryx, which lived approximately 150 million years ago. This ancient ancestor possessed feathers just like those of modern birds, but also possessed a mouthful of sharp teeth, wing claws, and a long bony tail like a true reptile. Archaeopteryx likely ran quickly and may have performed short gliding flights from branch to branch, though it was not as skilled a flyer as modern birds. Nevertheless, this creature became a crucial link connecting two worlds, the world of reptiles and the future world of birds. But feathers themselves didn't originally evolve for flight. Fossils show that even dinosaurs that never dreamed of taking to the air had feathers or feather-like structures. These coverings likely served to conserve heat, like a fur coat, or they served as a brightly colored attire to attract females, or perhaps as a camouflage coat to hide from predators. Only over time did feathers evolve, becoming lighter, wider, and more complex in structure. And eventually, some dinosaurs discovered that they could glide through the air or even actually fly. This discovery marked the beginning of a completely new era, when life began to explore the ocean of air. The end of the dinosaur era, approximately 66 million years ago, was an apocalypse that forever changed the face of Earth. A massive, mountain-sized asteroid slammed into our planet. The impact triggered firestorms, monstrous earthquakes, gigantic tsunamis, and finally plunged the world into a long period of darkness and cold, known as the impact winter. Most large dinosaurs did not survive this catastrophe, but some smaller bird-like dinosaurs managed to survive. Their salvation lay in their small size, their ability to feed on whatever they could find, seeds, insects, carrion, and of course, their ability to fly, which allowed them to move to safer places. These few survivors became the ancestors of all modern birds without exception. From this moment on, a completely new, exciting era began in the long history of avian evolution. When the dinosaur world collapsed, many ecological niches became vacant. With the disappearance of the giant reptiles, new horizons opened up for the survivors, including small birds. They began to spread across the planet, experimenting with a wide variety of lifestyles. Over millions of years, these birds evolved, taking on an incredible diversity of forms depending on their environment. Some of them evolved into powerful flyers, capable of crossing entire oceans. Others, conversely, became large and heavy, abandoning flight entirely to dominate the land. Some developed long, slender beaks to extract nectar from deep within flowers, while others acquired powerful, sharp beaks designed for cracking nuts or tearing flesh. Gradually, birds became one of the most successful and diverse groups of animals on the planet, and one of the main tools in this monumental transformation was the beak. Unlike mammals, birds have no teeth. Instead, they have developed a stunning variety of beaks which serve them to perform thousands of different tasks. Bird beaks come in the most bizarre shapes and sizes, and each one is perfectly adapted to its function. For example, a hummingbird's beak is long and thin, like a needle, allowing it to easily sip nectar from the deepest flowers. A woodpecker's beak, by contrast, is strong and sharp as a chisel, allowing it to effortlessly drill into wood in search of grubs. And a parrot's beak is curved and incredibly powerful, making it the perfect tool for cracking hard nuts. Imagine a world where every tool is designed for survival. A finch's beak, for example, is a true power tool, powerful and short, perfectly adapted to easily crack the hard shells of seeds and nuts. And consider the raptors soaring in the skies. Hawks and eagles are armed with beaks curved like scimitars, the perfect tools for rend the flesh of their prey after a swift and merciless hunt. Ducks, being aquatic creatures, have broad, flattened bills that act as a perfect natural filter, sifting edible particles from river mud. This astonishing diversity of form clearly demonstrates how evolution has honed every detail, allowing birds to occupy their unique niches in the great theater of nature. But the bill is only half the story. The true key to their aerial dominance is their wings, and there's no room for uniformity here. Each wing shape is a distinct strategy, opening up entirely new horizons for the bird. We see species with long, narrow wings as if designed for endless soaring. They can hang suspended in air currents for hours, barely exerting any effort. Albatrosses, Diomedeidae, those ocean wanderers, possess precisely these long, pointed wings, allowing them to glide over the waves, covering thousands of kilometers in their epic journeys. Others, on the contrary, have short, wide, rounded wings. This design is for speed and maneuverability, for lightning-fast leaps and sharp turns. Look at pigeons and sparrows, which dart with incredible agility through the maze of city streets or dense forests. And hummingbirds are a marvel of engineering in their own right. Their wings are capable of vibrating at such a frequency and angle that the bird can literally freeze in place in midair. No other bird has mastered this art to such perfection. It is precisely this infinite diversity in wing structure that has allowed birds to become the absolute masters of the skies. Millions of years passed, and the descendants of dinosaurs spread across the planet. They learned to survive in the most unimaginable conditions, from scorching desert sands and humid tropical jungles to the icy Arctic tundra and the vast expanses of the world's oceans. Take penguins, for example. These creatures deliberately abandoned the sky, transforming their wings into powerful flippers. They became unrivaled divers, veritable underwater torpedoes, masterfully hunting fish in the icy waters of Antarctica. Ostriches, Struthiocamelus by contrast, have relied on the land. Their strategy is not flight, but a blazing run, allowing them to escape any danger. Emus, their Australian cousins, also rely on their incredibly strong and long legs to sprint across the savanna rather than soar through the clouds. In the harsh silence of the Arctic, snowy owls, Bubo scandiacus, have perfected the art of camouflage. Their plumage blends seamlessly with the surrounding snowy landscape. Meanwhile, on the other side of the world, in the riot of tropical forest colors, vibrant parrots and toucans use their flashy plumage to make a statement against the lush greenery. These birds have conquered virtually any ecosystem, and their bodies have evolved to perfectly meet the challenges of this world. Birdsong is more than just a delight for our ears. It's a complex language, a vital aspect of their existence. Males perform their arias to win the heart of a female, and many species use shrill cries to mark their territory or sound the alarm at the sight of a predator. Over time, these vocal signals have become increasingly sophisticated and complex. Virtuosos such as nightingales, mockingbirds, and lyrebirds have developed an astonishing ability not only to perform intricate melodies, but also to masterfully imitate the sounds of other animals and even the sounds of the surrounding world. This musical talent of birds demonstrates how profoundly evolution has affected not only their physiology but also their behavior and methods of communication. Flight itself is one of the greatest miracles born of evolution, but taking to the air required more than just feathers. Birds' skeletons underwent dramatic changes. Their bones became hollow, making their entire bodies incredibly light. Their pectoral muscles developed into a powerful engine capable of propelling their wings at incredible speeds, and their respiratory system evolved into a super-efficient mechanism for delivering oxygen to working muscles. All of these adaptations working in unison gave them the ability to fly. This allowed them to cross vast distances, inhabit remote islands, and easily evade land-based predators. Migration is perhaps the most impressive manifestation of this gift. Just imagine some birds, like the Arctic tern, Sterna paradisea, annually undertake an incredible journey from the Arctic Circle to the south and back, covering tens of thousands of kilometers. Such grandiose flights clearly demonstrate how the gift of flight opened up almost the entire planet to them. Birds are one of the most dynamically evolving groups of living creatures. After the asteroid ended the age of dinosaurs, their diversity began to grow exponentially. Scientists believe that in the millions of years following this global catastrophe, birds experienced a veritable evolutionary explosion. This process is known as adaptive radiation. Each vacated ecological niche presented them with new challenges and opportunities, and they adapted with astonishing speed. In regenerating forests, some species became specialized fruit eaters, simultaneously dispersing seeds and helping the forest grow. In the vast grasslands, others became skilled insect hunters. Waterfowl emerged near rivers and lakes, growing long legs and necks to confidently navigate shallow water. And this incredible diversity continues to grow today. Today, science recognizes over 10,000 bird species, making them one of the most numerous and diverse groups of vertebrates on Earth. Now look more closely, and you'll see the unbreakable connection between modern birds and their distant ancestors, the dinosaurs. Chickens, pigeons, and indeed all other birds still bear the imprint of their ancient past. Entire ecosystems ignited like matches, filling the air with choking smoke. The impact sent billions of tons of dust and vaporized rock high into the atmosphere, creating a dense, impenetrable shroud around the planet. This shroud of dust and soot completely blocked out sunlight for months, perhaps even years, plunging the world into the darkness of eternal night. Without sunlight, plants began to wither. The planet's green heart, upon which all life depended, began to wither. Forests fell silent. Fields of giant ferns turned to dust, and the once thriving ecosystem began to rapidly collapse. Deprived of food, the herbivorous dinosaurs were the first to perish. Then, without prey, mighty predators like Tyrannosaurus rex fell. Slowly but surely, the giants fell one after another, slain not so much by the blow itself as by its horrific aftermath. This event set off a chain reaction of irreversible change. With each passing day, the planet's temperature dropped lower and lower. The so-called impact winter had arrived. Imagine a world where the sky remains black for years, where icy winds rip through dead landscapes, and the roar of dinosaurs and the songs of prehistoric birds are replaced by a ringing silence. This is precisely what the world became after the asteroid impact. Dinosaurs, who had survived battles with predators, droughts, and floods for millions of years, were confronted by an enemy they could not defeat. Their world was destroyed. Even the tiny sparrow bears the legacy of giant lizards, evident in the structure of its bones, in every feather, and in its habits. When we watch a chicken scratch the ground with its paw in search of food, or a hawk stare motionless and intently at its prey, we seem to glimpse a ghostly reflection of that distant era when their ancestors ruled the planet undisputed. Plumage, the ability to fly, and even the nest-building instinct, all these are chapters of one great and rich story. Birds have always fascinated humans. Their ability to fly has become an enduring symbol of freedom and unattainable dreams. In ancient civilizations, they were often deified, associated with powerful gods or the immortal human soul. For centuries, people studied their seasonal migrations, admired their complex mating dances, and listened to their songs. Later, with the development of science, scientists began to look at birds more closely, attempting to unravel the mysteries of evolution. It was Charles Darwin, while visiting the Galapagos Islands, who noticed the differences in the beaks of the local finches. He noted that each species had a unique beak shape, ideally suited to a specific type of food. These observations formed the basis of his revolutionary theory of natural selection, which became the cornerstone of all modern biology. To this day, the great story of bird evolution continues to unfold before our eyes. Paleontologists never cease their search, uncovering more and more fossils that, like fragments of a mosaic, help us piece together missing pages of their past. Ancient ancestors of birds, some of which sported toothed jaws and clawed wingtips, lift the veil of mystery on their remarkable transformation. And modern genetic analysis sheds light on how different bird species are related to each other and the routes they took as they dispersed across the globe. With each new discovery, we add new touches to the grand canvas depicting how birds became what we know them as. But their journey is far from over. Today, birds face new, unprecedented challenges created by human activity. Habitat destruction, global climate change, and widespread pollution threaten the survival of many species. Just as during the great extinction that ended the age of dinosaurs, birds are once again desperately having to adapt to a rapidly changing world. The future of these amazing creatures, like all life on Earth, now depends on whether they can continue to evolve and whether we humans learn to care for the fragile world on which we all depend. The demise of such majestic creatures as Tyrannosaurus rex and Triceratops was one of the most dramatic and transformative moments in the history of life on Earth. For millions of years, these giants reigned supreme, shaping entire ecosystems and leaving behind fossils that still captivate the imagination of people around the world. Their sudden and almost instantaneous disappearance marked not just the end of their reign, but also the final chord of an entire era, the Age of Dinosaurs, which lasted over 160 million years. To fully understand why these mighty creatures vanished into oblivion, we must travel back to the final chapter of their story, the end of the Cretaceous period. Approximately 66 million years ago, the planet itself was rocked by monstrous cataclysms. The events that unfolded at that time were so devastating that they wiped out almost 3/4 of all living species from the face of the earth. Tyrannosaurus rex, or simply T-Rex, has become in our minds the absolute embodiment of primal might, undeniable power, and all-consuming terror. This lizard was one of the largest predators ever to walk the earth. Its body stretched 12 meters in length, stood 6 meters high at the hip, and weighed over 7 tons, the equivalent of an entire African elephant. Its skull was a veritable battering ram, and its jaws were studded with banana-sized teeth, capable of easily crushing bone with a single crushing bite. But Tyrannosaurus rex was more than just brute force. For its time, it was a remarkably intelligent hunter. Its forward-facing eyes gave it binocular vision and allowed it to accurately assess the distance to its prey, while its phenomenal sense of smell allowed it to sniff out prey from miles away. This apex predator terrorized the entire territory of modern North America during the last millions of years before the Great Catastrophe. Triceratops, on the other hand, was a herbivorous giant, but no less imposing. It was a veritable living fortress on 4 powerful legs, crowned with 3 formidable horns. 2 long horns grew directly above the eyes, and a third, shorter one was located on the nose, which served both for defense and to demonstrate its strength. Triceratops was a striking creature with a terrifying appearance. A huge bony frill, or frill, rose behind its head, likely protecting its vulnerable neck from the jaws of predators like T-Rex, and could also have been used to attract mates during mating season or to intimidate rivals. This dinosaur could grow up to 9 meters in length and weigh up to 10 tons. Despite its herbivorous diet, it was far from harmless. Its horns and massive build made it a formidable opponent, capable of fending off any predator and inflicting mortal wounds. Imagine these ancient landscapes. For millions of years, mighty creatures like Triceratops ruled these plains. They moved slowly in vast herds, tearing down dense vegetation and literally shaping the ecosystem around them. These 2 titans, Tyrannosaurus and Triceratops, embody 2 sides of the eternal drama of survival. On one side, the perfect hunter; on the other, the invincible protector, predator, and prey. Their confrontation lasted for countless generations, forcing each to hone their skills, adapt to new challenges, and thrive in a world full of deadly threats and unpredictable twists of fate. But despite all their strength, all their evolutionary prowess, they proved powerless in the face of the truly extraordinary events that befell Earth at the very end of the Cretaceous period. The catastrophe that ended their long reign is believed to have occurred on a single fateful day, approximately 6 million years ago. A gigantic asteroid, a rock nearly 10 kilometers across, hurtled toward our planet from the depths of space. It entered the atmosphere and slammed into Earth at colossal speed in what is now Mexico's Yucatan Peninsula. The force of this impact was unimaginable. It released energy equivalent to the explosion of billions of atomic bombs. In an instant, mountain ranges vaporized, and a monstrous scar, a crater nearly 200 kilometers in diameter, was formed in the Earth's crust. The explosion threw trillions of tons of molten debris into the sky, which rained down on the surface like fiery rain, sparking apocalyptic-scale forest fires across the planet. Entire continents were engulfed in flames. Powerful earthquakes shook the earth, and the ocean swelled, generating gigantic tsunamis that washed away everything in their path. The world was plunged into chaos almost instantly. However, this was only the beginning of the end. The impact sent colossal amounts of dust, soot, and sulfur into the atmosphere. This dense pall blocked out sunlight for months, perhaps even years, plunging the planet into darkness and cold. Deprived of light, plants could no longer photosynthesize and began to die en masse. For herbivorous dinosaurs like Triceratops, this meant starvation. With their food supply gone, they began to die out. And then came the predators. With the herbivores gone, even the mighty Tyrannosaurus rex was left without a food source. This set off a deadly chain reaction that completely destroyed the fragile balance of life on the planet. The Earth's temperature plummeted, ushering in a period scientists call a shock winter. The planet became a cold, dark, and completely inhospitable place. It was a global event, beyond the capabilities of even the most powerful and adaptable creatures. For years, paleontologists have debated whether the asteroid was the sole cause of the Great Dying or whether other, equally devastating factors played a role. Today, much evidence suggests that the cosmic visitor was not the sole culprit of the tragedy, but rather dealt a decisive blow to an already weakened world. Around the same time, on the other side of the planet, in the region of modern-day India, massive volcanic eruptions known as the Deccan Traps were occurring. For millions of years, gigantic lava flows erupted from cracks in the Earth's crust, spewing tons of ash and toxic gases into the atmosphere. These eruptions could have seriously undermined the health of ecosystems even before the asteroid impact. The climate was already changing, and the air and water were poisoned. It's likely that the combination of these two catastrophes, the impact from space and the fires from the Earth's interior, created the perfect storm that left even the most resilient species no chance of survival. Let's travel back to the world of dinosaurs just before the catastrophe. It's important to understand that this was a thriving planet teeming with life. Vast herds of Triceratops roamed the endless plains, browsing on ferns and the first flowering plants. Somewhere nearby, hidden in the shadows of the trees, a Tyrannosaurus stalked its prey, ready to pounce or fend off smaller predators. But the world wasn't limited to them. Alongside them lived other amazing creatures, herds of duck-billed hadrosaurs, armored ankylosaurs, nimble small predators, giant pterosaurs soared in the skies, and giant marine reptiles like mosasaur reigned supreme in the seas. It was a world of fierce competition, constant adaptation, and the struggle for survival. The sudden end of this era was a tragedy not only for these two famous dinosaurs. It marked the end of an entire era. The Tyrannosaurus and Triceratops fossils we find today are silent witnesses to their lives and their sudden demise. In some places, paleontologists have found Triceratops bones with characteristic tooth marks that perfectly match the jaws of a Tyrannosaurus. This is direct evidence of the brutal battles that unfolded across the vast expanses of the ancient world. Elsewhere, the skeletons of these giants are found in rock layers dating to just before the asteroid impact, but climb just a few centimeters higher on the geologic scale, to the layers formed after the impact, and their fossils vanish completely, as if someone had erased them from the pages of history. This abrupt break in the fossil record underscores how fatal and irreversible this extinction was. They, like many other species, simply failed to survive this threshold. It's hard to even imagine the final days of these creatures. The last Tyrannosaurus or the last Triceratops, roaming the dying earth, unaware of the cosmic scale of the catastrophe that had already occurred. Perhaps the last herds of Triceratops, weakened by hunger, struggled to find food under a dim, shrouded sky. Or perhaps the last Tyrannosaurus, transformed from an apex predator into a desperate scavenger, scavenged the remains of other dying animals until its strength gave out. Earth's greatest rulers fell not in battle with a more powerful adversary, but under the onslaught of devastating changes in nature itself. What makes their demise so significant is more than just the loss of incredible creatures. It's a stark reminder of how fragile life can be, even when it has thrived for millions of years. Over the course of their existence, these animals learn to adapt to any challenge, survive climate change, and dominate their ecosystems. But a single event, which took only an instant in cosmic time, was enough to destroy their world. Their story is a lesson in the unpredictability and ferocity of natural selection. It proves that even incredible strength, gigantic size, and evolutionary perfection are not always a guarantee of survival. Despite having disappeared from the face of the earth, Tyrannosaurus and Triceratops live on in our culture and imagination. Every new fossil unearthed from the earth evokes awe and wonder. Each bone is a fragment of a grand story, a link connecting us to a world millions of years removed. Museums around the world display their gigantic skeletons, reminding us of the incredible diversity of life that once existed on our planet. Film, books, and art bring them back to life again and again, evoking a mixture of awe and wonder. These amazing creatures have become symbols not only of extinction, but also of life's incredible resilience. Though their flesh and blood have long since turned to dust, their memory continues to haunt us. Their demise, paradoxically, opened the way for new life. Mammals, who had lived in the shadow of dinosaurs for millions of years, finally got their chance. In a desolate world, new opportunities opened up for them. Over time, these small furry creatures began to evolve, giving rise to an incredible diversity of forms, from tiny shrews to giant mammoths, and eventually to primates, and then to humans. In a sense, the fall of Tyrannosaurus and Triceratops allowed us to emerge on this planet. Their disappearance was both an end and a beginning, the conclusion of one great chapter in Earth history and the opening of a new one. If you think about it, the demise of such iconic dinosaurs isn't just a historical fact, it's a symbol of the monumental and sometimes catastrophic changes constantly unfolding on our planet. It's a story not only about the past, but also a dire warning about the future. It shows that life on Earth is always on the brink of great upheaval, whether a threat from space, from within the planet itself, or, as today, as a result of our own actions. Dinosaurs once ruled the world undisputed, and then they disappeared. And this raises the question that humanity too may face challenges beyond our control. The lesson of their story is simple. Survival depends on the ability to adapt, on resilience, and on the willingness to withstand the most unexpected blows of fate. Scientists continue to study these ancient creatures not just out of curiosity. They are particularly interested in the mechanism of extinction itself. Understanding how and why dinosaurs disappeared helps us see general patterns in how life responds to global catastrophes. But even in this hell, not all life died out. Some creatures found a way to survive in this new, hostile environment. Tiny mammals, who had lived for centuries in the shadow of giant lizards, demonstrated incredible resilience. They could hide in burrows to escape the cold, feed on surviving seeds and insects, and reproduce very quickly. Birds, whose ancestors were dinosaurs and survived this apocalypse, became a symbol of hope for the future revival of life. Even some groups of non-avian dinosaurs managed to hold on for a time, carrying the legacy of their ancestors into a new, dark era. Some species of reptiles and fish, as well as microscopic organisms such as plankton, survived in the oceans. Life was shattered, wounded, but not completely destroyed. The extinction of the dinosaurs was both the end of the world and the birth of a new one. It marked the end of the Cretaceous period, the final chapter in the age of dinosaurs, and ushered in the Paleogene period, a new era in the planet's history. The disappearance of the giant reptiles left a void at the top of the food chain. This paved the way for mammals, who could finally emerge from the shadows and begin their rise to dominance. Over the next millions of years, these small, hardy creatures evolved into countless forms, eventually giving rise to primates and, much later, humans themselves. In a sense, the asteroid that killed the dinosaurs also paved the way for our own existence. This knowledge allows us to understand how fragile ecosystems can be and how easily they can be destroyed. By studying the history of Tyrannosaurus and Triceratops, researchers are exploring the history of life itself, how it originated, flourished, and sometimes came to tragic ends. The disappearance of these incredible animals connects us to the deep past on an emotional level. Just imagine, 66 million years ago, living creatures walked this very earth, as real as today's elephants or whales, and the realization that their entire world was destroyed in an instant evokes awe. It's a reminder of how fleeting our own time is and our place in the grand history of the planet. This realization shows that every era has its giants, and every era sooner or later comes to an end. Many of us first encountered dinosaurs as children, seeing the epic battle between Tyrannosaurus rex and Triceratops. Predator versus prey, teeth versus horns. This image is forever imprinted in our memories because it embodies all the drama of a long-gone world. However, in truth, the greatest battle these creatures faced wasn't with each other. It was with the planet itself, with forces of nature beyond their control. And in the end, neither survived, neither the all-powerful hunter nor the horned giant. Their bones, buried deep within the rock, remain silent witnesses to a catastrophe that forever changed the course of life on Earth. And the fossil record of the post-impact world is like a blank page, where the old story broke off to give way to a new one. Imagine the silent record left by the planet itself, a chronicle written not in words or ink, but in bones, shells, and other fossilized remains that tell us of a past so deep it almost defies imagination. ancient leaf imprints, plant spores, and the faint traces of creatures that once walked this earth, forever imprinted in stone and preserved for tens of millions of years. These pages of stone allow us to glimpse a world born from the ashes of a profound catastrophe. We travel back 66 million years to that fateful day when a colossal asteroid, hurtling from the depths of space, slammed into Earth, forever changing the course of life. This unique, violent, and instantaneous event brought an end to the age of the great dinosaurs, ending the reign of titans like Tyrannosaurus rex and the mighty Triceratops. However, the end of one era was the beginning of another. From the shadow of the giants, mammals, birds, and countless other groups of life emerged, given their chance to thrive. By studying the fossils left behind by this fiery baptism of the planet, we learn more than just which species survived the apocalypse. We see how these survivors adapted to a world of darkness, famine, and total destruction before slowly, step by step, entering a new era, an era of restoration and unprecedented opportunity. The rocks formed at this turning point form a distinct boundary in the Earth's crust, which scientists call the Cretaceous-Paleogene boundary, or the CPG boundary for short. In the fossil record, this is perhaps the sharpest and most dramatic line, marking the end of the age of dinosaurs and the birth of a new world. If you or I were to pick up a piece of rock from this layer, we would notice a thin strip of dark clay. It contains an anomalously high concentration of iridium, a rare metal that is almost never found on Earth, but is abundant in asteroids and comets. This iridium layer is like a scar from an impact, a global fingerprint left by a space alien in geological formations across the planet. Above this line, the picture of the fossil world changes beyond recognition. Mighty dinosaurs vanish. Along with them go the giant marine reptiles, the pterosaurs, rulers of the prehistoric skies, and countless species of plants and small organisms. But the remains found above this layer belong to the survivors. Before us are the fossils of resilient ferns, tiny mammals, some bird species, as well as crocodiles, turtles, and insects, those who managed to persevere amidst the chaos. One of the most striking pieces of evidence from those times is a phenomenon scientists call fern peak. In many parts of the world, paleontologists have discovered that immediately after the catastrophe, fossilized pollen and spores of ferns suddenly became dominant. This demonstrates that life in the oceans was forced to start virtually from scratch, rebuilding food chains from the smallest organisms upward. The fossils of these microscopic creatures provide some of the most compelling evidence of how deeply the ecosystem was destroyed and how slowly it subsequently recovered. On land, mammal fossils are a key source of information about how survival and opportunity went hand in hand. During the age of dinosaurs, mammals were predominantly small, shrew-like creatures that lived a secretive life in the shadow of giants. They were neither large nor dominant. But this may have been their greatest advantage. Fossils found in Paleogene rocks, the period immediately following the extinction of the dinosaurs, testify to a veritable explosion of mammal diversity. In just a few million years, their numbers and species diversity began to grow rapidly. They grew in size, occupied vacant ecological niches, and spread across a wide range of habitats. Fossil remains tell a story of astonishingly rapid adaptation. Small insectivorous mammals evolved into larger herbivores, predators and ultimately gave rise to the ancestors of modern primates, ungulates, and carnivores. Every fossil jaw, tooth, and skeletal fragment found in rocks from that time is like a page from the Great Book of Evolution, demonstrating how quickly life can fill a void. Bird fossils found around the world after the catastrophe also provide important clues. After all, dinosaurs didn't go extinct completely. Their descendants survived, but they weren't giants with teeth and claws, but small feathered creatures we call birds today. Fossil finds show that those groups of birds that had a specialized diet, such as feeding exclusively on seeds, had a much better chance of survival. Seeds could lie in the ground for decades, surviving periods of darkness and cold, only to germinate when conditions became favorable again. And while other food was unavailable, seed-eating birds had a constant and reliable source of food. Over time, these surviving species evolved into the incredible diversity of birds we see today, from songbirds to giant waterfowl. They are a living reminder that even in the darkest times, resilience finds a way to continue the ancient dinosaur line, albeit in a new guise. Another fascinating piece of fossil evidence concerns insects. Fossils of insects themselves and traces of their activity, such as characteristic bite marks on fossilized leaves, prove that they too survived and adapted remarkably well. Some groups even took advantage of the new conditions, feeding on the vast amounts of dead organic matter left behind by the catastrophe. Fossilized termite nests and beetle burrows indicate that insects quickly reclaimed their role as the primary waste processors in nature, helping ecosystems restore nutrient cycles after the massive devastation. Without their tireless work, the regeneration of forests and the restoration of balanced food chains would have taken much longer. When we look at the fossil record of freshwater inhabitants, such as turtles, crocodiles, and amphibians, we see that many of them successfully survived the collision. Fossilized turtle shells and bones are found both before and after the fateful boundary, testifying to their remarkable resilience. Perhaps their secret lay in their ability to live in water, burrow deep into the mud, and go for long periods without feeding. Crocodiles, thanks to their indiscriminate diet and aquatic lifestyle, also reliably appear in the fossil record after the catastrophe. Their fossils, virtually unchanged from their prehistoric ancestors, remind us that survival doesn't always depend on strength or speed. Sometimes it's the ability to adapt and the endurance to weather any storm that makes all the difference. But the fossil record also reveals something else, a period of global calm. In the rock layers immediately above the impact boundary, fossil finds become strikingly scarce. This gap reflects a terrifying time when ecosystems were virtually devastated, when extinction claimed so many lives that a deafening silence descended upon the planet. This silence in stone is as eloquent as the fossils themselves. It reminds us of a moment when life itself hung by a thread, when survival was in doubt and recovery seemed impossible. However, layer by layer, the fossils are gradually returning, testifying that the world has finally begun to recover. One of the most detailed and shocking pieces of evidence revealing the history of this post-catastrophe world is located in North Dakota, USA, at a site called Tanis. Here, paleontologists have discovered unique fossils that preserve a picture of what happened in the first hours and days after the asteroid impact. The remains of fish with tiny glassy spheres in their gills were discovered. Scientists believe these are droplets of molten rock ejected into the atmosphere by the monstrous explosion and rained down as fiery rain thousands of kilometers from the impact site. These fish died instantly, buried under giant sage waves that swept through rivers and lakes far from the ocean. This site is like a snapshot of the catastrophe itself, capturing the primordial chaos that paved the way for the birth of a new world. And both at Tanis and elsewhere around the world, the stones continue to hold these astonishing stories. The stone record, frozen in time, tells us a remarkable story of how slowly the shattered planet recovered. The impact itself and the initial devastation were monstrously swift. The catastrophe did not drag on for centuries. The great dying, like a firestorm, swept across the planet in just a few terrifying years. But this brief, violent finale was followed by an agonizingly long process of healing, lasting millions of years. And yet, life clung on. The first to rise from the ashes were the most undemanding. Fern spores surviving the inferno sprouted on the scorched earth, covering it with a green carpet. In the murky ocean waters, tiny planktonic organisms, the foundation of all marine life, began to reproduce rapidly, returning to their familiar cycle. But others were less fortunate. Grand ecosystems where giant mammals reigned or lush gardens of new plants flourished required entire eons to return. Studying layers of fossils, paleontologists, like detectives of the past, piece by piece reconstruct this renaissance, tracing how many millennia passed before biodiversity even approached what it had been before the asteroid impact. This chronicle tells not of a miraculous and instantaneous resurrection, but of a slow, uneven, and painful journey forward. It demonstrates the Earth's incredible resilience, its capacity for self-healing, but on timescales difficult for the human mind to even imagine. Looking at the fossil record, we also notice that the recovery unfolded differently in different parts of the planet. In some regions, certain groups of life managed to survive the catastrophe better than their counterparts elsewhere. For example, in the lands we now know as South America, fossils of ancient mammals reveal a surprisingly early burst of diversity. Meanwhile, on other continents, life recovered much more slowly. Looking back on this ancient event, we are struck by how a single moment can forever change the trajectory of life on an entire planet. Just one cosmic rock, landing in the right place, at the right angle, and at the right speed, ended the age of dinosaurs and rewrote the fate of our world. Even today, scientists, like detectives, continue to explore the Chicxulub crater and the geological layers of that era. They are finding irrefutable evidence of that catastrophe. Shocked quartz, tiny glass droplets known as tektites, and a thin layer of iridium, a rare metal much more common in asteroids than in Earth's crust. These discoveries prove that the demise of the dinosaurs was not a slow decline. It was a sudden, devastating blow from the heavens. A story carved in stone awaits us to piece together. The thought of an asteroid impact evokes both fear and awe. It shows us how cruel space can be, where silent wanderers of rock and ice can shape the fate of entire worlds. But it also demonstrates the incredible resilience of life. which, despite monstrous upheavals, managed not only to survive, but to adapt and flourish again. Without this remarkable quality, Earth might still be in the hands of dinosaurs, and humanity might never have come into being. When we wander the halls of museums and gaze upon the majestic skeletons of creatures like Tyrannosaurus rex or Triceratops, they remind us of that long-forgotten world. These bones are more than just the remains of ancient animals. The bones of early mammals, the shells of marine plankton, fern spores, fish teeth, and bird wing prints, all these fragments together form a picture of a world simultaneously broken and healing. For millions of years after the asteroid impact, our planet underwent colossal transformations, and life sought and found new, uncharted paths for its development. Without fossils, we could only speculate about what happened during those dark times. But thanks to them, we can observe every stage of this great restoration in astonishing detail. When we talk about the end of the dinosaur era, our imaginations often conjure up a single dramatic scene: the impact of a giant asteroid, which occurred approximately 66 million years ago. This apocalyptic moment has gone down in history as the event that killed the great dinosaurs. And in many ways, this is true. It was the final crushing blow. However, the true story of their extinction is far more complex and multifaceted than a simple impact of a space rock. Millions of years before the fireball pierced the atmosphere, the dinosaur world was already beginning to crumble. The climate was slowly but inexorably changing, transforming landscapes, depleting food sources, and creating new harsh conditions for survival. It tested the endurance of even the most powerful and adaptable creatures. The asteroid may have been the sudden executioner that ended their reign, but it was climate change that acted as a slow but merciless killer, sapping their strength and leaving them vulnerable to the coming catastrophe. To truly understand this drama, we need to imagine the world not as the stage for a single apocalyptic event, but as a slowly unfolding play in which the very scenery gradually shifted until the central actors were trapped. Throughout the long Mesozoic era, which lasted more than 180 million years, dinosaurs flourished in a stunning variety of forms. For most of this time, Earth's climate was paradisical, warm and incredibly stable. Dense, lush forests covered every continent, even those now frozen solid. Sea levels were higher, creating vast, shallow seas where plains now lie. This warm and hospitable world allowed dinosaurs to spread across virtually the entire planet. They were true masters of the Earth, mastering a wide variety of ecosystems from parched deserts to coastal swamps. They evolved into giants like the long-necked sauropods, ferocious predators like the legendary Tyrannosaurus rex, and powerful herbivores protected by armor and horns like Triceratops. However, nothing lasts forever. Over time, the planet itself, its atmosphere, oceans, and continents began to change, gradually creating entirely new rules of the game for dinosaurs. These global shifts became one of the key forces determining their future fate. In the late age of dinosaurs, continental movement became a decisive factor. The ancient supercontinent Pangaea, which once united almost all of the planet's landmass, had long since broken apart. For millions of years, its fragments continued to drift further and further apart. This radically altered the contours of the oceans and the paths of global currents that transported heat and moisture across the globe. As tectonic plates shifted, new mountain ranges emerged. Ancient seas opened and closed, and coastlines constantly shifted. All these geological processes inevitably affected the lives of dinosaurs. Precipitation patterns, wind directions, seasonal temperature fluctuations all began to shift, creating challenges for creatures accustomed to stability. Changes in these conditions could have made their lives unbearably difficult. For example, when the continents finally separated, the climate inland became noticeably drier. Moist ocean winds could no longer easily reach the central regions. As a result, once lush forests began to shrink, giving way to more open woodlands or arid plains. Dinosaurs, who depended on dense forests for food and shelter, were forced to adapt to new, more open landscapes. Some succeeded, but many others began a desperate struggle for survival. Over time, this gradual loss of their familiar habitat weakened entire populations, making them more vulnerable to any other threats. At the same time, another powerful force entered the global picture: volcanic activity. Massive eruptions released unimaginable volumes of carbon dioxide and other greenhouse gases into the atmosphere. And these weren't short-lived explosions like those of modern volcanoes. Imagine gigantic faults in the Earth's crust, from which streams of molten lava flowed continuously for hundreds of thousands of years, covering entire regions with a thick layer of basalt. One of the most striking examples of such events is the Deccan Traps in modern-day India. These colossal eruptions began long before the asteroid impact and triggered sharp global temperature fluctuations. At times, the planet heated up dramatically, plunging it into a greenhouse hell. At other times, complex chemical reactions in the atmosphere and oceans, on the contrary, led to cooling. For all life on the planet, these alternating heat and cold temperatures were a source of constant stress. Dinosaurs, like all other animals, were adapted to a specific climate and available food. When the world became too hot, even polar regions once comfortable for life turned into scorched earth, destroying local flora and fauna. And when periods of cold weather arrived, tropical and subtropical zones lost some of the lush vegetation on which countless herds of herbivorous dinosaurs depended. These climate swings, unrelated to the asteroid, may not have killed instantly, but over millions of years they placed enormous stress on all ecosystems on the planet. Another important part of this story is the impact of climate on plants. Dinosaurs were inextricably linked to plant life. Herbivores fed on it directly, and predators fed on it indirectly by hunting herbivores. In the late Cretaceous, flowering plants began to rapidly spread across the planet. At first glance, this seems like a positive change, but it had a downside. Older vegetation types, such as conifers and cycads, which served as the main food source for many giant dinosaurs, began to retreat. Climate change only accelerated this process. In regions with altered rainfall patterns, the structure of the vegetation could change beyond recognition. Some dinosaurs, especially the enormous species that required tons of food every day, had extreme difficulty adapting to such changes. Every day, the world changed subtly, and these changes affected the lives of its giant inhabitants. In some regions, a trend toward cooling and drying led to the formation of more open, savanna-like landscapes. Although true grasses had not yet appeared, dinosaurs adapted to life in dense forests suddenly found themselves with nowhere to hide or build nests. For predators, this meant their prey became more visible and vulnerable. Imagine the delicate balance of power in the wild, where the slightest change can give a predator a decisive advantage or, conversely, make it vulnerable and its prey a chance to escape. This eternal dance between hunter and prey was constantly disrupted by the onslaught of global climate shifts. It's important to understand that climate change didn't occur in a vacuum. It was part of a grand symphony of natural forces. For example, global sea levels rose and fell, directly linked to climate cycles. These fluctuations continually reshaped coastlines, creating entirely new ecosystems on newly flooded plains. In some eras, such changes led to the complete extinction of entire species that hadn't had time to adapt. During the dinosaurs' heyday, vast but shallow seas covered much of the land. They created a warm, humid greenhouse effect, ideal for a thriving ecosystem. But as these seas began to retreat, arid, harsh regions with much less vegetation began to form in the interiors of the continents. Dinosaurs, who had thrived for centuries along these hospitable coastlines, were faced with a choice: either migrate in search of new lands or try to survive in inhospitable conditions that could no longer provide them with their former abundance. The fossil record silently testifies. By the end of the Cretaceous, some great dinosaur dynasties were already drawing to a close. Sauropods, those colossal titans with incredibly long necks that had been the hallmark of earlier eras, had become veritable rarities in many corners of the planet. The diversity of large predators also began to decline. And yet, despite this, iconic species like Tyrannosaurus rex and Triceratops continued on, like the last bastions of an ancient, fading civilization. Their lineages were still strong, but they no longer boasted the staggering diversity they had once possessed. Climate change, coupled with the transformation of plant life and the loss of traditional habitats, likely played a key role in this long, slow decline. Now let's consider how these climate storms might have affected the most intimate aspects of life: reproduction and the survival of offspring. Most dinosaurs laid their eggs and nests directly on the ground. Climate fluctuations made nesting sites incredibly vulnerable. A sudden flood could wash away an entire generation. A prolonged drought could incinerate clutches in the scorching sun, and extreme temperature fluctuations could destroy the fragile life within the shells. If several consecutive nesting seasons were unsuccessful, populations began to dwindle before our eyes, even without mass mortality of adults. Climate disruptions could also have disrupted centuries-old migration routes, or shifted the timing of seasonal food availability. For species whose survival depended on precise natural cycles, even a slight shift in timing could eventually lead to catastrophic population declines. All these factors meant one thing: by the time the asteroid struck 66 million years ago, dinosaurs were already living in an increasingly hostile world. They weren't doomed. After all, they had millions of years of survival under constant change. But they were under enormous pressure. Climate change slowly but surely sapped their strength, reducing their numbers and diversity. Fewer and fewer species remained, and their populations became increasingly fragmented and small. This made them mortally vulnerable, and when an asteroid strike unleashed a sudden chaos of firestorms, pitch darkness, and global cooling on the planet. The dinosaurs no longer had the resilience that could have saved them in better times. Imagine two different worlds. In one, dinosaurs are at the height of their power. Countless species thrive in every corner of the planet. Their populations are strong, and their genetic diversity allows them to adapt easily. In such a world, even after the most terrible catastrophe, there will be enough survivors to start anew. And now the second world, the one that was reality. A world where dinosaurs are becoming increasingly rare, their habitat shrinking like shagreen, and their diet becoming increasingly meager. Their populations are already under stress due to a series of climate shocks. In such a weakened state, a sudden catastrophe becomes insurmountable. The final nail in the coffin. Historical evidence etched in stone confirms that the second scenario was the reality. However, this doesn't mean that climate alone could have wiped out the dinosaurs. After all, they survived numerous previous climate shocks, including periods of global warming and ice ages, fluctuating sea levels, and massive volcanic eruptions. But it was the lethal combination of the unstable climate of the late Cretaceous period and the asteroid impact that proved fatal. Climate change was a slow, debilitating process that gradually weakened dinosaurs and made them vulnerable. The asteroid, however, was a sudden, crushing hammer blow that completed what had begun as a slow strangulation. When we reflect on this, we understand a simple truth. Extinction is rarely the result of a single cause. More often, it is a chain of interconnected events that weaken a species over time until a sudden shock puts the final nail in the coffin. In the dinosaurs' story, climate change was the long-term factor that set the stage for tragedy. The fossil record beautifully reveals this drama. In rock layers dating to the last few million years before the asteroid impact, we see how the number of dinosaur species plummeted in some regions. Fossilized pollen tells the story of how forests changed. Old tree species disappeared, replaced by new flowering plants that not all herbivores could adapt to. Ancient soils bear traces of brutal cycles of drought and flood. Even chemical analysis of rocks reveals fluctuations in carbon dioxide levels, changes in ocean composition, and continental shifts, all markers of global climate shifts. All this evidence adds up to a picture. The world was becoming increasingly complex for giant reptiles long before the Death Star fell from the sky. Throughout Earth's history, climate has repeatedly played the role of a great sculptor, shaping life itself. Sometimes its chisel was slow, almost imperceptible changes, and sometimes sudden, devastating blows. For the dinosaurs, this was a long and agonizing period of pressure that weakened their world from within. Without this pressure, they might have survived the asteroid impact, demonstrating their legendary resilience, but they were too weakened to withstand the final knockout blow. As we look back on the history of our planet, few events can compare in their drama and impact to the great dying that marked the end of the age of dinosaurs. This event, some 66 million years ago, was more than just the disappearance of the giant reptiles that once ruled the land, seas, and skies. It was a turning point that altered the entire balance of power on Earth. The disappearance of dinosaurs and countless other creatures opened a new chapter in the history of life. It cleared the way for entirely new species to emerge, adapt, and thrive in a world shaken to its very foundations. They are symbols of a bygone era. They seem to whisper to us of jungles that shook with thunderous footsteps, of seas where giant marine reptiles reigned, and of skies that once darkened beneath the wings of pterosaurs. And they also tell of that fiery day when a cosmic mountain crashed to Earth, ending it all. And yet, dinosaurs still live among us. The birds that perch on our windowsills, soar over the oceans, and sing in the forests are all their direct descendants. Every sparrow, every eagle, every swallow is a small link in that great chain of life that connects us to the distant past. Even the tiniest hummingbird carries echoes of this mighty lineage in its DNA. Life didn't perish with the asteroid. It simply continued on its path, finding new forms and possibilities. The Earth is still writing its own history, and the asteroid impact was one of its most dramatic chapters. The world that existed 66 million years ago was filled with roars and thunderous stomps. The cries of giant reptiles echoed across the endless forests that covered the continents like green oceans. It was a time when dinosaurs ruled, when enormous flying lizards glided over primordial seas, and our ancestors, strange and small mammals, hid in their shadows. But in an instant, everything changed. A rock more than 10 kilometers wide fell from the sky, hurtling toward the planet with inexorable force. Thus, the Great Dying was not only a tragedy, but also a source of incredible renewal, an act of survival and total transformation. To understand how this event shaped the future of the animal world, we must travel back in time and see the world before, during, and after this catastrophe. Then we must trace how life, clinging to every chance, struggled to recover over millions of years. Before the asteroid impact that forever changed the face of Earth, dinosaurs dominated the planet for over 160 million years. Their world was incredibly diverse. Imagine enormous herbivores like Brachiosaurus, which could stretch their necks to the crowns of the tallest trees, and ferocious hunters like Tyrannosaurus rex, whose mere presence struck terror into all living things. During the Mesozoic era, Earth was home to a multitude of amazing creatures, not only massive dinosaurs, but also smaller, agile, bird-like reptiles roamed the forests and plains. Alongside them, flying reptiles and pterosaurs conquered the skies. The oceans belonged to marine giants like mosasaurs and plesiosaurus. Mammals also existed during this era, but they were mostly small, shrew-like creatures that lived a secretive life in the dinosaur's shadow. They hid in burrows, hunted insects, and foraged under the cover of night. In the great drama of life at that time, dinosaurs were the stars, and mammals were mere extras. This balance of power seemed eternal, and perhaps it would have continued so if not for a sudden blow from the heavens. When a colossal asteroid approximately 10 kilometers wide slammed into Earth near what is now Mexico's Yucatan Peninsula, the world was instantly plunged into hell. The collision caused devastation on a planetary scale, releasing energy comparable to billions of nuclear bombs. An unimaginable amount of dust, soot, and ash was ejected into the atmosphere. These particles enveloped the planet like a thick shroud, blocking out sunlight and plunging it into a dark, icy night that likely lasted for months, perhaps even years. Without sunlight, plants couldn't photosynthesize and began to die en masse. As they perished, so did those who depended on them. Forests turned to arid wastelands, grasslands to lifeless deserts, and oceans became toxic. Firestorms swept across continents, gigantic tsunamis battered coastlines, and earthquakes shook the very foundations of the planet. It was a catastrophe of such magnitude that more than 3/4 of all life on Earth simply vanished. Among them were all the non-avian dinosaurs that had long been the undisputed rulers of the planet. In a single geological instant, their 160-million-year-old reign was overthrown. And yet, despite all the tragedy, it was this moment that shaped the future. When the dinosaurs were gone, a new dawn broke over the ruins of their world. It was a turning point, the greatest curtain to fall on the stage of evolution. A whole new world suddenly opened up to the countless creatures that had huddled for centuries in the dinosaur's shadow. Ecosystems once trodden by multi-ton colossi became desolate landscapes filled with untold possibilities. And here, in this new world, mammals got their chance. Those tiny creatures that survived the apocalypse, huddled in burrows and feeding on literally anything they could find. It wasn't strength that saved them, but versatility. Seeds, roots, insects, carrion. Their unpretentiousness became the key to survival. While mighty lizards found themselves helpless in the face of global change, our humble ancestors persevered, and their great story was only just beginning. For the first millions of years after the catastrophe, the planet healed its wounds. Life was fragile, almost ghostly, but it slowly, persistently, and inexorably rose from the ashes. The earliest mammals remained tiny after the fall of the dinosaurs, but they had already begun their timid but confident conquest of new territories. The opportunities presented by the disappearance of the giant lizards were truly colossal. Freed from the constant fear of being crushed or eaten, some mammals were able to pursue gigantism, while others invented entirely new survival strategies. Over millions of years, this led to a veritable explosion of evolutionary creativity. Some ventured back to the seas, giving rise to dynasties of whales, dolphins, and seals. Others took to the treetops, becoming the ancestors of apes and, ultimately, humanity itself. And still others remained to conquer the land, transforming into horses, elephants, saber-toothed cats, and countless other creatures that inhabit our planet today. Amazingly, it was the demise of the dinosaurs that allowed mammals to emerge from the shadows and become the new masters of the animal kingdom. However, they weren't the only ones to take advantage of this unique opportunity. The great dying had its benefits for others as well. Birds, the sole surviving heirs of the great dinosaur dynasty, also adapted brilliantly to the New World Order. These amazing birds, coexisting side by side with their gigantic relatives, were able to survive the catastrophe thanks to their saving graces, their tiny size, their ability to fly, and their unpretentious diet. After the extinction of the dinosaurs, birds launched a veritable expansion across the planet, filling the skies with their songs and adapting to every conceivable environment. Some evolved into powerful aerial hunters like eagles and falcons, while others took a different path, becoming flightless giants like ostriches and penguins. A world freed from the dominion of dinosaurs gave birds incredible freedom to evolve. This led to the emergence of thousands of species we know today. Every time we watch a fussy sparrow or see a hawk soaring overhead, we witness this rich legacy, born from the ashes of a great catastrophe. But the story of survival doesn't end there. Reptiles, seasoned veterans of evolution, also found ways to hold on in this changed world. Although their giant marine cousins like mosasaurs disappeared forever, turtles, lizards, snakes, and crocodiles managed to survive the Great Dying. These animals had aces up their sleeves that helped them endure. Crocodiles, for example, could go months without food and found refuge in rivers and swamps, the ecosystems that suffered the least. Turtles and lizards were small, unpretentious, and could make do with a meager diet. Snakes, being incredibly flexible and versatile predators, thrived in the new environment, eventually spreading across the globe. Although reptiles never regained their former dominance, their resilience and adaptability allowed them to occupy an important niche in the history of life and continue their evolution. Moreover, the extinction completely reshaped life in the oceans. When the giant marine reptiles disappeared, a power vacuum was created, which new groups of animals immediately began to fill. Sharks, which had already plied the seas for hundreds of millions of years, survived another apocalypse and emerged even stronger, giving rise to numerous new forms and becoming some of the planet's top predators. Bony fish also experienced an explosion of diversity, filling the waters with a dazzling kaleidoscope of species. They were soon joined by returning mammals such as whales and dolphins, creating an entirely new balance of power in the deep sea. The old rulers of the seas were gone, but their throne was not vacant for long. Insects and other small creatures also played a key role in the formation of the new Earth. The destruction of most of the vegetation was a devastating blow to them, forcing them to adapt or perish. Here, mammals were forced to evolve to adapt to the new conditions. However, the insects' phenomenal ability to reproduce quickly and en masse gave them a huge advantage. They began to develop a close relationship with flowering plants, which, after their extinction, received a powerful boost in their spread. Thus, new, strong alliances between pollinators and plants were born. This partnership between insects and flowers literally shaped the modern landscapes we know today. Today, our meadows and forests are ablaze with vibrant colors and the buzz of bees, butterflies, and other pollinators. Without that catastrophe, the development of these complex ecosystems might have taken much longer. But the extinction essentially pushed the accelerator, gifting the world with vibrant new forms of collaboration between flora and fauna. Over millions of years, Earth transformed into a gigantic laboratory of evolution. And all this became possible because dinosaurs cleared the stage. Mammals filled every conceivable niche, giving rise to forms from tiny shrews to gigantic mammoths. Birds conquered the skies and became one of the most diverse animal groups on Earth. Reptiles continued their adaptive journey. Insects and flowering plants created thriving ecosystems. Even amphibians found new habitats in this transformed world. Thus, the Great Dying became a kind of total reset, the starting point for a new era of life, an era that ultimately led to the emergence of the world as we know it. Perhaps the most fascinating part of this story is how it ultimately led to our emergence. Imagine, if dinosaurs hadn't disappeared, mammals would have remained small, nocturnal creatures hiding in the undergrowth. Without their explosive development, primates likely never would have emerged. And without primates, the path to humans would have been forever blocked. It turns out that the asteroid that ended the age of dinosaurs was the cosmic messenger that ushered in the age of humans. It cleared the way for our species. Every time we look at our reflection, we see a distant echo of that ancient catastrophe. Extinction isn't just an event from the distant past. It has shaped our very existence and the very nature of every animal with whom we share the planet. Today's inhabitants of Earth, whether lions in the African savanna, polar bears in the Arctic, dolphins in the oceans, or even the cat sleeping in our laps, are all part of this long history. They are the descendants of those who survived, heirs to creatures that lived through the darkest times in the planet's history. Every feather, every claw, every footprint, and every songbird's trill is a reminder of life's incredible resilience and how a single catastrophe can forever alter the future. This is a story not only of loss, but also of triumph, not only of an ending, but also of a great beginning. The extinction that destroyed so much simultaneously created the ground for new wonders to emerge. In this, we see how evolution and natural selection continue their eternal work, shaping our world. The demise of the dinosaurs was not just a tragedy for these majestic creatures, but also a crucial lesson in the history of life on Earth. It demonstrated that even the most powerful creatures are utterly defenseless in the face of sudden global change. This experience demonstrated that survival often depends not on size and strength, but on adaptability, flexibility, and resilience. And from this greatest crisis came a renewal that led to the creation of a world no less rich and diverse than the one that came before. If we look at this event from an even greater perspective, we see it as part of a larger picture. Throughout Earth's history, several mass extinctions have occurred, each wiping out countless species. However, each time, life found a way to recover, evolving in new, often completely unexpected directions. The extinction of the dinosaurs was just one such turning point, perhaps the most famous, but not the only one. It reshaped the tree of life in ways no one could have predicted. This story reminds us that our planet has never been static. It is constantly changing, constantly evolving, finding new ways to fill the void left by those gone forever. And today, when we see the incredible diversity of life around us, from the tiniest insect to the gigantic blue whale, we see the living legacy of that ancient catastrophe. It was this catastrophe that shaped the ancestors of these creatures, opened up new evolutionary paths for them, and created the very ecosystems they now inhabit. Nothing human-made could compare to the force of that blow. The dinosaurs, who dominated this planet for over 160 million years, had no idea that on that very day, their era would be cut short forever. The impact was so powerful that our imagination simply refuses to conjure up such images. But this was only the trigger, the first chords in a symphony of destruction. It was followed by fires, earthquakes, and mega tsunamis that swept across the planet in a matter of moments. To grasp the scale of the catastrophe, let's transport ourselves to that world and see what it looked like in those first minutes, hours, and days after the impact of the celestial visitor. The asteroid pierced the atmosphere with incredible speed. It flew faster than a fired bullet, faster than sound, faster than anything the giant lizards could have imagined. As it sliced through the air, it left a fiery trail behind, heating the atmosphere to such a degree that the skies must have been ablaze even before the rock touched the ground. When it finally struck the surface, it vaporized in an instant, taking with it a huge chunk of the Earth's crust. Solid rock turned into red-hot plasma. The ocean waters at the epicenter boiled. At the impact site, the explosion left a monstrous scar, a crater over 150 kilometers wide and 20 kilometers deep. It seemed the planet itself had sustained a wound that would never fully heal. The first consequence was fire. The unimaginable amount of energy released could not remain static. The collision generated a shock wave of superheated gas that shot high into the atmosphere, carrying molten rock, dust, and vaporized material from the asteroid with it. These clouds rose far beyond visibility and then rained down fiery debris on entire continents. Each tiny particle returning to Earth ignited in the atmosphere like a falling meteor, scorching the skies and setting fire to the forests below. Imagine this scene. And when it struck the shallows off the coast of modern-day Mexico, it unleashed an energy greater than all the nuclear weapons ever created on Earth. History was rewritten by fire. For millions of years, they adapted to their surroundings, witnessing the rise and fall of entire dinosaur dynasties. But their greatest chance, their turning point in history, came at the very end of the Cretaceous period, when catastrophe came from the heavens. Imagine this day. Not far from the coast of modern-day Mexico near the Yucatan Peninsula, a cosmic visitor crashes into Earth. A fireball more than 10 kilometers wide, hurtling at unimaginable speed. In an instant, the world changes beyond recognition. The skies above the planet ablaze. Shock waves like the wrath of Earth itself rolled across the continents, shaking them to their foundations. Ancient oceans boiled, and gigantic tsunamis crashed onto the coastlines. But this was only the beginning of the end. In the following months and years, trillions of tons of dust and ash rose into the atmosphere. They enveloped the planet like a thick shroud, completely blocking out sunlight. The world was plunged into an eternal, bone-chilling winter. Temperatures plummeted, halting the vital process of photosynthesis. Plants, the foundation of all food chains, began to wither and die. Entire ecosystems collapsed before our eyes. For the giant dinosaurs, who required mountains of food to survive, this was a death sentence. If you stood anywhere on the planet, you would see the entire horizon filled with fiery streaks of light. Millions of shooting stars, all erupting simultaneously, but instead of dying out, they ignited trees, bushes, and the very ground beneath their feet. Fires engulfed thousands of square kilometers. Entire prehistoric jungles turned into raging seas of flame. The air filled with acrid smoke, and the bright day gave way to a darkness comparable to the deepest night. For the dinosaurs caught at the epicenter of this inferno, history ended. In the first seconds after the impact, they found themselves trapped amidst blazing forests, choking on ash and smoke. with no chance of escaping this fiery inferno that stretched to the horizon. However, the fires were only part of the general chaos. The earth itself shook in violent agony. The impact released energy that swept through the Earth's crust in seismic waves of unimaginable force. This shock was equivalent to hundreds of the most powerful earthquakes occurring simultaneously around the world. In some places, the ground literally cracked and split apart, forming gigantic fissures. Mountains shook as if they were made of sand. Volcanoes dormant thousands of kilometers away could awaken and erupt, spewing streams of lava and even more ash into the atmosphere. Earthquakes swept across the continents, felling ancient forests and triggering monstrous landslides that buried all life. Lowlands were submerged and entire ecosystems were destroyed and submerged. In a single day, countless animal and plant species were wiped off the face of the earth. As for marine life, the sudden change in water composition, temperature, and currents proved fatal. Coral reefs were crushed to dust, and shallow water ecosystems simply ceased to exist. Even deep-sea creatures likely suffered from the enormous amount of sediment and debris that sank to the bottom, blocking their access to sunlight. To better understand this chain of events, let's imagine the chronology. In the first seconds after the impact, a blinding flash, brighter than the sun itself, incinerated everything within a radius of hundreds of kilometers. Minutes later, shock waves swept across the planet, shaking it with powerful earthquakes, surpassing any tremors ever recorded by humans. Within hours, red-hot debris rained from the sky, causing global forest fires, and gigantic tsunamis slammed into coastlines thousands of kilometers from the epicenter. The Earth was transformed not gradually, but rapidly, almost instantly. The inhabitants of that time simply couldn't comprehend what was happening. Dinosaurs, who had been peacefully grazing in the forests that morning, now gazed at the blazing skies, felt the trembling earth, and saw walls of water advancing from the ocean. Pterosaurs, gracefully soaring over the prehistoric seas, were torn from the skies by the hurricane-force winds unleashed by the explosion, and mammals, still small and timid at the time, hid in deep underground burrows. Perhaps this is precisely what gave them a better chance of survival than others. Large reptiles living on the surface had to face a veritable nightmare of fire, water, and crumbling rocks. The fires alone could have wiped out countless dinosaurs and other creatures. Entire regions were transformed into barren, parched deserts. Smoke and soot clouded the skies, plunging the world into darkness even before the long, catastrophic winter set in. Earthquakes reshaped the landscape, creating new lakes where rivers shifted their courses and new mountain ranges where the Earth's crust heaved. Tsunamis obliterated coastlines, leaving no trace of once thriving coastal ecosystems. It seemed as if nature's three most destructive elements, fire, earth, and water, had united in a single terrifying moment to deal a devastating blow to life. One of the most frightening aspects of these events is how quickly they spread across the globe. Unlike slow climate change, which takes millennia, this all happened in an instant. The catastrophe that ended an era of millions of years unfolded in just a few hours and days. By the end of the first day, the world was unrecognizable. Earthquakes could continue as aftershocks, striking again as the Earth's crust regained its equilibrium. Tsunamis could strike the coast again and again, inundating it again and again. The survivors had no peace, and the chaos continued. The Earth was in turmoil. Everything that had once seemed eternal and immutable was destroyed. Gone were the days when dinosaurs reigned supreme. The continents were stable, and day followed predictably into night. The immediate aftermath of the asteroid impact was merely a prelude to a much longer and more painful process of extinction. Fires, earthquakes, and tsunamis were only the opening acts of this global tragedy. They were followed by darkness, cold, and famine, as dust and soot lingered in the atmosphere for years. But even amid all these horrors, the image of those first moments when the skies burned, the earth trembled, and the oceans rose remains one of the most terrifying and simultaneously majestic events in the history of our planet. It was the day when the earth itself seemed determined to erase everything that had come before, clearing the way for a new chapter in the history of life. The explosion itself was incredibly powerful, but the real danger didn't end with the dying of the fireball, the fading of the shock waves, or the retreat of the giant tsunamis. It was only the beginning. It seems paradoxical, but we owe our existence to the greatest catastrophe in the history of the planet. In the truest sense of the word, it was this mass extinction that made our modern world what it is. Without it, who knows? Perhaps giant dinosaurs would still be shaking the earth, and our mammalian ancestors would have languished in the shadow of these colossi. But instead, life took a sharp turn, rushing toward a future no one could have imagined. Let's fast forward millions of years. Our planet's oceans were teeming with life, but their fate was destined to change forever. When a colossal mountain-sized asteroid slammed into Earth, it not only sealed the death knell for dinosaurs on land, its shockwave also rippled through the world's oceans, transforming them just as powerfully and for millennia to come. The seas of that distant era were strikingly different from those we know today. Imagine a world where colossal reptiles patrolled the waters, where fish of the most bizarre shapes swam, where mysterious creatures resembling squid in spiral shells lived, and where coral reefs stretched for hundreds of kilometers. The catastrophe that ended the age of dinosaurs did not spare this underwater world. The marine environment underwent colossal, almost unimaginable changes. It took millions of years for ocean life to reassemble itself, giving rise to entirely new ecosystems that ultimately led to the rich and diverse seas we see today. The asteroid's impact released energy comparable to the simultaneous detonation of billions of nuclear bombs. Trillions of tons of rock, ash, and dust were thrown into the sky, and the planet became darker than the darkest moonless night. A darkness descended on Earth that scientists estimate could have lasted for months, and possibly even years. On land, this sudden darkness was a death sentence for plants. Without sunlight, they withered, followed by starvation, followed by the herbivorous dinosaurs, and then the predators. A similar drama unfolded in the oceans. The vast majority of marine life depended directly on sunlight. Tiny floating plants, called phytoplankton, formed the foundation of the entire food chain. These microscopic ocean gardens, like all plants, required light for photosynthesis. As the sky darkened, the sun's rays could no longer penetrate the thick veil of dust, and the phytoplankton began to die en masse. Without it, starvation awaited the small animals that fed on it, such as zooplankton, and without these tiny creatures, larger fish, reptiles, and all other predators were deprived of food. It was a catastrophe of planetary proportions. All life in the seas, from the very bottom to the top of the food chain, faced the most serious challenge in its entire history. One of the groups most severely affected were the ammonites. These marine animals, distant relatives of modern squid and octopuses, sported spiraling shells. They were true evolutionary veterans, surviving multiple mass extinctions and thriving for hundreds of millions of years. The seas were literally teeming with them in a wide variety of shapes and sizes. However, after the asteroid impact, a massive food shortage and a dramatic change in water chemistry led to their complete and irreversible disappearance. Their extinction freed up vast evolutionary space in the oceans which other creatures could eventually occupy. The same fate befell giant marine reptiles such as mosasaurs, Mosasaurus, and plesiosaurs, Plesiosauria. These enormous, ruthless hunters who ruled the seas as unchallenged as tyrannosaurs on land vanished forever. They left behind vast voids in the ecosystem which were eventually filled by entirely new groups of animals. Coral reefs, some of the most vibrant and important habitats in the ocean, also suffered a terrible blow. Many ancient reefs were built not by modern corals, but by marine creatures called rudists, bivalves. However, these skilled builders were completely destroyed during the cataclysm, and the reefs became dead, lifeless ghost cities. Millions of years passed before new coral species, more similar to those we know, began to dominate and slowly rebuild these underwater metropolises. The disappearance of the reefs meant that countless species of fish and other small creatures lost their home overnight. But even in the face of such total destruction, life found a way to adapt and regenerate. Some groups of animals managed to survive the catastrophe, and they went on to shape the oceans of the future. Take sharks, for example. They survived the extinction despite losing many of their species. But enough of those that survived were able to eventually occupy new niches in marine ecosystems. The same can be said of bony fishes, the ancestors of most modern species. After the extinction, they experienced a veritable evolutionary explosion, giving rise to an incredible diversity of shapes and sizes. They filled all the gaps in the food chain and became the dominant group in the oceans. Another group of survivors were tiny plankton, which built their shells from calcium carbonate. Many of these species were wiped out, but some managed to survive the darkest and most difficult years after the impact. These surviving species gave rise to all modern plankton, which still drifts in our seas. Since plankton is the foundation of the ocean food chain, its restoration was absolutely essential for the revival of the entire marine ecosystem. Over time, as the dust in the atmosphere settled, light returned and conditions stabilized, plankton began to proliferate again. Following suit, other marine life began to recover and thrive, becoming increasingly diverse. During the age of dinosaurs, the whales and dolphins we know today didn't yet exist. However, their distant ancestors, small land mammals, managed to survive the catastrophe. Millions of years later, some of these land animals accomplished the unthinkable. They returned to the sea and evolved into the first whales. Some fell victim to terrible starvation, others simply froze in the ensuing cold. An entire world that had thrived for millions of years was destroyed practically overnight. And when the dust finally settled, when the skies became clear and bright again, the non-avian dinosaurs were no more. Their long 100-million-year reign had come to an end. However, for our little mammal heroes, this cosmic tragedy became a ticket to the future. What had once been their weakness, their limitation, their tiny size, now turned into their greatest advantage. They required far less food, meaning they had a better chance of finding sustenance in a devastated world where every root was precious. Their ability to eat almost anything became the key to survival. Their diet included insects, seeds, roots, and the remains of other animals. This omnivorousness gave them incredible flexibility when their usual food sources disappeared. Deep underground burrows protected them from the hellish heat and firestorms that raged on the surface immediately after the impact. And their nocturnal lifestyle helped them adapt perfectly to the dense darkness that enveloped the planet for many years. Let's pause for a moment and grasp the scale of this turning point. For over 160 million years, dinosaurs reigned supreme on Earth. Their success allowed them to become the most numerous vertebrates in modern seas. When you observe schools of fish, you can feel the entire history of these creatures unfolding before your eyes. You're looking at the descendants of those who managed to survive the hell that destroyed the dinosaurs. And now, they reigned supreme in the seas that were emptied by the disappearance of the ancient giants. Seabirds also began to gain increasing importance during this period. During the age of dinosaurs, enormous flying reptiles known as pterosaurs dominated the skies above the oceans. However, an asteroid impact led to their complete extinction, and birds were able to take their place. Some evolved into skilled fish hunters, dropping like stones into the water in search of prey. Others developed the unique ability to fly vast distances over the ocean. Over time, seabirds became an integral part of marine ecosystems, connecting land and sea in a unique way. In the millions of years following the extinction, the seas became a veritable testing ground for new evolutionary experiments in nature. Marine mammals, such as whales and seals, emerged in the oceans. Birds adapted to life on the coasts and in the open sea. Sharks and rays evolved into a myriad of forms. Corals once again built magnificent reefs, creating habitats for countless fish. All these changes were only possible because the asteroid destroyed the ancient rulers of the sea, giving the survivors the chance to evolve in entirely new directions. If we look at today's oceans, with their astonishing diversity of life, we see a direct consequence of that ancient catastrophe. If not for the asteroid, ammonites would still be swimming in the seas, and giant reptiles would be the top predators. However, today's seas are filled with whales, dolphins, seabirds, modern corals, and an incredible diversity of fish. The marine world we see today is the result of survival, adaptation, and millions of years of evolution following the global collapse. For years, the oceans recovered from one of the most massive catastrophes in the history of our planet. They endured a period of perpetual darkness, acidification, and the complete collapse of food chains. However, over time, they emerged as unique ecosystems full of wonder. Every living creature in the modern ocean, from the tiniest plankton to the gigantic blue whales, preserves a story of survival and rebirth that began on that fateful day 66 million years ago. However, the true horror began not in the first moments after the impact, but in the long months and years that followed. The catastrophe proved far more insidious and devastating than the explosion itself. The planet, once a warm and vibrant world, began to rapidly transform into an icy and silent desert. Paleontologists dub this phenomenon impact winter. To fully grasp the scale of the tragedy, let's travel back 66 million years and witness the apocalypse. The chain reaction of destruction set in motion on that fateful day lasted for decades. Imagine a mountain-sized rock hurtling from the depths of space. This colossal asteroid, several kilometers wide, slams into Earth at an incredible speed near the Yucatan Peninsula, which we now know as part of Mexico. The moment of impact releases an energy unimaginable. Compare it to the power of billions of atomic bombs detonated at a single point, in an instant. The impact leaves a monstrous wound in the Earth's crust, a crater more than 12 kilometers deep and over 100 kilometers in diameter. Billions of tons of rock, dirt, vaporized rock, and wood soar into the sky. The force of the explosion was so colossal that many of these fragments were propelled into the stratosphere, from where they began to fall back, heating the atmosphere to red-hot temperatures. Wildfires erupted across the planet, turning entire continents into fiery infernos. Oceans boiled, generating gigantic tsunamis that crashed onto coastlines. Earthquakes shook the very earth, shaking the continents. But all this was merely a prelude. The most terrifying weapon of this catastrophe rose into the sky. An unimaginable amount of dust, ash, and vaporized rock was ejected into the atmosphere. Added to this was smoke and soot from the planet-wide forest fires. As if that weren't enough, the impact triggered volcanic activity worldwide, sending new batches of ash and toxic gases into the sky. All these tiny particles rose high into the stratosphere, far above the layers where rain clouds form. Normally, rain would have washed all the dust out of the air over time, clearing it. But this deadly curtain hung where rain simply couldn't reach. This meant that the dark particles would remain in the sky for a very, very long time. As debris and soot spread through the atmosphere, the sky began to darken. Let's move on to the surface. Imagine standing in the middle of a clear day and watching the sun begin to dim. The light weakens as if a thick, dark blanket had been thrown over the sun itself. At first, it might have seemed like an ordinary thunderstorm approaching, but as days passed, then weeks, the darkness only deepened. The layer of particles in the atmosphere became so dense that the sun's rays could no longer penetrate to the Earth's surface. According to scientists' calculations, just a few days after the impact, the planet was plunged into eternal twilight. In some regions, near total impenetrable darkness set in, lasting for months. This sudden loss of sunlight had immediate and catastrophic consequences. The great wilting began. Plants, those silent factories of life powered by sunlight, were cut off from their energy source. Photosynthesis, the foundation of all life, halted. They could no longer produce food. In some regions, rain could cease for years, condemning them to drought, while others were battered by violent storms as the planet struggled to restore its disturbed balance. But perhaps the most frightening aspect of the impact winter was its duration. The soot and dust in the sky didn't clear within a week or a month. By some estimates, the Earth remained in pitch darkness for several years. For the first few months, there was almost no light on the surface, and even after the darkest period had passed, the sky remained cloudy and dim for a very long time. Full sunlight may not have returned for nearly a decade. All this time, surviving plants struggled to grow, animals starved, and ecosystems continued to collapse. To understand how horrific this was, let's recall one event from human history, the eruption of Mount Tambora in Indonesia in 1815. This single eruption was so powerful that the ash it spewed into the sky caused what has been called the year without a summer. Europe and North America suffered terrible crop failures, and millions of people went hungry. Now imagine that not just one volcano's ash was released into the atmosphere, but thousands of times that amount, blocking sunlight across the entire planet at once. This only gives a faint idea of the horror that followed the asteroid impact. This led to a total collapse of the food chain. Without plants and plankton, herbivorous dinosaurs were doomed to starvation. Once they disappeared, the same fate befell the predators. Dinosaurs, which had ruled the Earth for over 160 million years, found themselves powerless in the face of the sudden disappearance of food. However, some small creatures managed to find ways to survive. Insects, rodents, some amphibians, and reptiles demonstrated remarkable adaptability. Crocodiles, for example, could survive in water by feeding on carrion, and turtles could go months without food. But for large land reptiles, whether giant herbivores or ferocious predators like Tyrannosaurus rex, the doom had already been pronounced. The impact winter also altered the chemical composition of the atmosphere. Massive fires released massive amounts of carbon dioxide into the air. Furthermore, the asteroid struck sulfur-rich rocks. These compounds, entering the atmosphere, mixed with water vapor to form sulfuric acid. Acid rain fell on Earth, poisoning lakes, rivers, and soil. The few plants that could have survived the darkness now perished from acid burns that damaged their leaves and roots. Aquatic life also suffered. Acid rain altered the chemical composition of rivers and oceans, making survival even more difficult for fish and marine life. The oceans became hostile for another reason as well. Carbon dioxide, which had accumulated in the atmosphere, was actively absorbed by seawater, leading to ocean acidification. The acid began to corrode the shells and skeletons of marine organisms, corals, mollusks, and tiny plankton, such as foraminifera. With the disappearance of this plankton, entire ocean food chains collapsed. Seas that once teemed with giant reptiles and shoals of fish became nearly lifeless deserts. It's perhaps difficult for modern humans to even imagine the world in such a state. We're accustomed to sunlight, to the changing seasons, to a rhythm of life defined by warmth and light. But for many years after the catastrophe, Earth was a planet of cold, darkness, and silence. Forests stood charred and dead. Fields were covered in a layer of ash, and the acrid smell of smoke and decay hung in the air. The sky must have glowed with an eerie, unearthly light, a reddish or brown haze through which the sun's rays barely pierced. Nights were pitch black, as even moonlight was absorbed by the dense veil in the atmosphere. The world must have seemed one endless night that would never end. The few who survived this hell did so through incredible luck and adaptability. Some mammals hid in deep burrows, feeding on stored food or insects. Birds, distant descendants of dinosaurs, also managed to survive the catastrophe, perhaps thanks to their ability to find seeds that could lie dormant in the ground for long periods. These seeds, hidden in the soil, bided their time. When sunlight finally returned, they were able to germinate, giving life a new chance to regenerate. Slowly, after years of darkness, the sky began to clear. The sun returned, and plants once again reached for the light. However, the recovery process was excruciatingly slow. It took hundreds of thousands of years for ecosystems to recover, and millions of years for evolution to give rise to new species to fill the empty niches left by dinosaurs. The impact, winter forever, changed the face of life on Earth. It cleared the way for the evolution of mammals, which ultimately led to the emergence of primates and then humans. The destruction of plant life and the collapse of food chains is one of the most terrifying and at the same time fascinating events in the history of our planet. To grasp the scale of such a catastrophe, one must understand how fragile the balance of life is. Plants, which seem mundane to us, are in fact the foundation of virtually every living system on Earth. They are silent workers who convert the sun's energy into food and oxygen. Without them, life as we know it would be impossible. And when something severs this green thread, the world is plunged into darkness. Something colossal and utterly unforeseen descends upon the planet, destroying the very conditions that support plant life. The consequences of this catastrophe, like a shockwave, spread across the globe, reaching even the most secluded and remote corners. And at that moment, it becomes clear. Even the most powerful creatures on Earth are merely hostages to nature's mercy.